chant of exodus from the city where hunger, starvation, and death held the sway. To bring this chant to all, I shall say a word of revelation. To the farmer who mourns year by year for his labor in the farm that has become like drops of water on the mountain top which disappear at the heat. To the farmer who at the sound of rain should rejoice but rather crouched, for though harvest brings joy, the worms that eat up the crops visit before the harvest. We have a chant of joy. Our sun has risen, and we cannot but announce that good science has given us new technology, a transgenic weapon to tackle low crop yield, climate change, insect attacks, and deliver bumper harvest. It's modern biotechnology. Here is my story. Over the years, food insecurity remains one of the major problems of modern
Also representing the DG I would like to bring on to the high table Mrs. Bello Scholastica. Please, a round of applause for her. Okay, I would also like to bring to the high table the country coordinator program for biosafety systems, PBS, Dr. Matthew Daw. Please, a round of applause for him. Then I would also like to bring to the high table the former BSM president, Professor Ubi Benjamin Franklin. A round of applause for him. Also, I would like to bring to the high table Professor Chidi Ihu Egu, Dean Faculty of Natural Sciences. A round of applause for him. So can we please now rise for the national anthem? After the count of 2. 1, 2. Abraham. hand over the microphone to Professor Chidi for the opening prayer.
Let us pray. Oh Lord, our Heavenly Father, we thank you for the opportunity for us to be here today. You know the purpose of this gathering. May we be enlightened and join our colleagues in other continents to be able to read what science knowledge is providing. May we also benefit from the rich contributions for those who will be presenting one paper or the other today. At the end, Lord, may we have us to glorify your name. In Jesus' mighty name, we pray.
Amen. Thank you very much, sir. Can we please have our seats?
Thank you very much for that. The the Vice Chancellor, Geoffrey Okoye University, Enugu, our father, Reverend Father Professor Christian Anyeke, ably represented by the Deputy Vice Chancellor Admin, Professor Jose Ogudu, the Director General, National Biotechnology Research and Development Agency, Professor Abdullah Mustafa, who is online with us, the representative of the Director General, National Biosafety Management Agency, Mrs. Bello Scholastica, the Country Coordinator of Programs for Biosafety System, Dr. Matthew Doe, the former President, BSN, Professor Obi Benjamin, the Director, Agricultural Biotechnology Department, Dr. Rose Maxwell Gilado, the Director, Directorate of Interdisciplinary Research, Dr. C.O. Onya, the Director of Research and Molecular Biology, UNESCO, Mr. Dr. Amin Ambora, the Dean, Faculty of Natural Sciences and Environmental Studies, Professor Chidi, the President, BSN, Professor Sylvia, who is with us online, ladies and gentlemen of the press, ladies and gentlemen, I welcome you all to a one-day Biosafety and Biotechnology Sensitization Workshop for the Southeast Zone with the theme GM Food, Safety, Stewardship, Fortifying Public Confidence, taking place at Geoffrey Okoye University, Enugu.
Thank you very much, sir. To take us further, it is our primary responsibility to keep you informed of why we are all gathered here. And in a moment, I would like to invite, for the objective of the meeting, the head of ABA unit of the National Biotechnology Research and Development Agency, Mrs. Sarah Iwajuwan, to give us the objective. Please, a round of applause for her.
Good morning, PC. Please permit me to stand up the media protocol. Good morning, everyone. Good morning, everyone. Good morning. Okay. You're welcome to this one-day sensitization workshop for the Southeast Zone. on the biotechnology and biosafety. It's my pleasure, and I'm so happy that you all are here. Before we start with the activities that are lined up today, I want to introduce the objective for this program. This workshop is meant to equip you all with the knowledge and tools necessary to harness the potential of biotechnology for sustainable agri-development while addressing concerns related to its adoption and implementation. The objectives are to increase your awareness on the benefits of agri-biotech crops and to clarify misconceptions and concerns surrounding the safety of biotechnological products, and to empower you all with knowledge and skills to make an informed decision regarding the adoption of biotechnological practices, and also to foster dialogue and exchange of ideas between all of us in order to know the role of biotechnology has in shaping the future of agricultural biotechnology. And at the end of this program, we expect that we all have an in-depth understanding of the scientific aspects of agriculture to form an individual opinion on GMO, and awareness will be created on the maximum benefits from the potentials that biotechnology has to offer. And also, at the end, we have a network of concerned individuals for a continued exchange of information, expertise, and experience will be established. Thank you, and I pray that you will be actively present for this program. Thank you.
Okay, thank you, Sarah, for that insightful information. So to take us further, I would like to invite for remarks the Dean, Biological Sciences and Environmental Sciences, to come and give us a remark. A round of applause for him. Sorry, there's a little mix-up. I would like to invite the VC Vice Chancellor of Godfrey Okoye University, represented by Professor Goze, to give us an opening remark. Please, a round of applause for him. A round of applause for him.
Good morning, everybody. First of all, let me express the apology of the Vice Chancellor, who was waiting in his office to be personally here to declare this workshop open. And a few minutes ago, he called and informed me that something just came up, which necessitated that he have to leave the office, and therefore asked that I should represent him in this workshop. So let me first of all welcome all of you. For those of you who arrived yesterday, the VC had welcomed you when we paid a courtesy visit to him in his office. And for those of you who are joining us this morning, I want you to know that the Vice Chancellor welcomes all of you very warmly to this very important workshop. As you all know, this workshop cannot come at a better time given what every Nigerian is facing today with respect to food insecurity. The cost of food is increasing on a daily basis, shortage of food everywhere, and everybody is feeling the impact of the low productivity and the high cost of food in the country. Therefore, this workshop is very, very timely, very, very important, and I believe will address a very present challenge to our national existence. I therefore welcome all of you, thank all the organizers of this workshop, welcome all the delegates who are coming from different parts of the Southeast, who are here, and those who are still on the way. I hope that with the array of experts in the field, given the program which I have looked at, that this workshop will fill the gap in knowledge and also equip everybody on how best to maximize the potentials of science and what science can do for us in addressing this food insecurity. So, having said that, let me then read for you the official opening address of the Vice Chancellor. This is the opening address at the sensitization workshop for farmers, extension agents, state governments, MBAs, and the academia in the Southeast geopolitical zone of Nigeria by the Vice Chancellor of Okoye University, Reverend Father Professor Christian Aneke. The concept of modern biotechnology and the adoption of its products is relatively new in Nigeria. Biotechnology has wide application to the improvement of the life of anything that has DNA, spanning the disciplines of agriculture, environment, medicines, etc. With newer telecom for safe applications, especially new now that artificial intelligence AI is integral in the roadmap towards achieving the same objectives of improving productivity, quality of food crops, and income of farmers. To achieve a comprehensive understanding, adoption, and acceptance of agricultural biotechnology, it is important to sensitize the Southeast world on the benefits of biotechnology and its safety to counter most health-related claims made by the antis in this region. Godfrey University has always been in the forefront of advancement of biotechnology in Nigeria, being one of the first, if not the first, to mount biotechnology as a course, with approved curriculum by agency both at undergraduate and postgraduate levels. We recently graduated a postgraduate student in forensic biotechnology. Our relationship with NBMA and NABDA started when Godfrey University hosted our first international conference of biotechnology and national development, BICOBAC conference in 2013, and NABDA featured prominently and signed a memorandum of understanding with the two agencies. In 2014, our university hosted the first NBMS National Conference that brought together heads of relevant institutions, prominent scientists, farmers, and entrepreneurs to discuss and enlighten all the regulatory framework and procedures involved in the development of applications of biotechnology in Nigeria. Thereafter, GoUni hosted the first National Biosafety Society Conference in 2015, which was well organized and attended and set the precedence for subsequent programs. At the international level, GoUni is the host university For DNA Learning Center, Nigeria's DNA LLC Nigeria, this 7th in the world and the only one in Africa with the following mission. Modern biotechnology is gradually gaining strategic space in national discourse in Nigeria, especially with the commercialization of beet, cotton, and BBR cowpea. Farmers in the northern and southern zones are well sensitized and have adopted these for their commercial needs. There is, therefore, a need to organize sensitive social biotechnology and biosafety advocacy program for selected farmers, extension agents, state governments, and NDAs in the Southeast. The adoption and commercialization of 2 GMO crops, beet cowpea and beet cotton, as a result of a massive awareness campaign by Oxfam Nigeria. It is also necessary that all stakeholders and regions be sufficiently engaged and enlightened to increase the acceptance of these GMOs in Nigeria, despite the activities of the anti groups. Many of the concerns among the public are due to negative information which the public gives more attention to than positive ones. This calls for a need to intensify training and workshops for stakeholders on the role of NBMA in regulating the use of GM crops, as well as approvals and the benefits of the adoption and acceptance of GMOs for economic growth. This proposal is for the sensitization of the Southeast Geopolitical Zone, which comprises 5 states: Enugu, Abia, Anambra, Imo, and Ebonyi states. The last biotech sensitization workshop for the Southeast was held in March 2021. To adequately carry the grassroots along, it is important that this becomes an annual event, as is done in other zones in Nigeria. Justification. The concept of modern biotechnology is relatively new in Nigeria. The need for safe biotechnology applications, especially in agriculture, is integral in the roadmap towards achieving the set objectives of improving productivity, quality of food crops, and income of farmers. In order to achieve a comprehensive understanding, adoption, and acceptance of agricultural biotechnology, it is important to sensitize the Southeast zone on the benefits of biotech and its safety to counter most health-related claims made by the antis in this region. The workshop objectives, as was read out, are clear to us. And the outcomes of this workshop include the following. Number 1, a more informed public on GMOs. Number 2, the extension agents will now work as BT crops advocates, spreading the good news and the advantages of beet crops over its conventional counterparts, thereby leading to more adoption of the already released crops varieties. Number 3, the workshop will bring about awareness among the farming communities in the Southeast of the availability of beet crops and how to plant them, and it will in turn lead to great adoption of the newly commercialized crop varieties within the shortest possible time. Number 4, OFAG will achieve more public understanding of GM technology and will gain more visibility for its activities. Number 5, a network of concerned individuals for continued exchange of information, expertise, and experiences established. Number 6, in-depth understanding of the scientific aspects of biotechnology, risk assessment, and risk management provided. In conclusion, this workshop aims to address the agricultural needs in Southeast Zone while fostering knowledge sharing and collaboration. On that note, distinguished ladies and gentlemen, my dear students, I welcome you all to this workshop, and I hope that by the end of this workshop, you will be tremendously enriched in the knowledge and the benefits of GMO and how it can facilitate greater agricultural productivity in Nigeria and help us to address this threatening food insecurity in the country. Thank you very much, and you are welcome to this workshop. Thank you.
Thank you very much, sir. Thank you for the warm welcome. It was powerful and insightful. We really appreciate it. Another round of applause for him. So to take us further, I would like to invite the Dean for the remark.
The Vice Chancellor and members of the High Group, participants, and my students. My Vice Chancellor has spoken to who am I to ask. However, may I add one or two things to what he has said? I am glad that this workshop, the anchor person is in my faculty, Dr. C.O. Onye, and this shall be doing every other time. This is the third. I would like the participant and the facilitator to explain more on what GMO is and the hybridization, and why are people kicking against it. In order to remove this idea of GMO, I want researchers to go into research to find out the nutrient component of GMO products and the natural organic products to see if there is difference or no or not. And based on that, I think those who are kicking against this, when they see that the GMO products and the organic products, there's no difference. The different contents are the same. I think those who are kicking against it will no longer kick against it. And also to adhere the fears of the negative impacts of GMO products to human beings, especially some are claiming that herbicides are what the main purpose of the GMO, but I want this workshop to help us prove that that is not true. And at the end, I think all of us should move forward together towards GMO in plants, animals, and food. And at the end, we will no longer be behind following others who will be competing actively with other clients where GMO products have become the order of the day. Thank you for coming to my faculty.
Thank you very much, sir. Okay, I will also want to recognize the presence of my DG CEO, Professor Abdullahi Mustafa, who is online with us. Can we please put a round of applause for him? For our next remark, I would like to invite Mr. Okoro, DNA Learning Center, Nigeria. Please, a round of applause for him.
Good morning, distinguished audience. Standing on already created protocols, I'm here to represent my director, Professor George Uday, the director of the DNA Learning Center, Nigeria, here at Godfrey University. It is both an honor and privilege to stand before you today at this esteemed gathering hosted by the National Biotechnology Agency in collaboration with the National Biotechnology Research and Development Agency, OFA, PVS, Godfrey Okoye University, and other agencies that are part of this collaboration. We have convened to deliberate on the crucial theme of GM food safety stewardship, fortifying public confidence. We embark on a journey of profound significance, one that underscores our collective responsibility in ensuring the safety and sustainability of our food supply in the age of biotechnology. At the heart of our discussions lies a fundamental truth. The assurance of food safety is not merely a regulatory obligation, but a moral imperative, a duty we owe to every citizen, present and future. In an era marked by rapid advancements in genetic modification and GM technologies, the need to foster public confidence in the safety of genetically modified foods assumes paramount importance. In our pursuit of this noble objective, we must recognize, first, the pivotal role played by the hands-on laboratory experience in the development of biotechnology. Laboratory work serves as a crucible where theory converges with practice, where scientific inquiry transcends the confines of textbooks and takes flight into the realm of innovation. It is here, amidst the hum of centrifuges and the dance of microorganisms, that the future of biotechnology is shaped. At the Bill Learning Center, Nigeria, Godfrey Okoye University, the importance of hands-on laboratory experience cannot be overstated. It is a cornerstone upon which the structure of biotechnological advancement is built. Through experiential learning, young, aging, and even aspiring scientists not only acquire technical proficiency, but also cultivate a profound appreciation for the rigors and nuances of scientific inquiry. They learn to navigate the complexities of genetic manipulation with precision and prudence, mindful always of the ethical imperatives that accompany such endeavors. Moreover, laboratory experience fosters a culture of collaboration and mentorship, wherein seasoned researchers impart their knowledge and expertise to the next generation of innovators. This symbiotic relationship between mentor and mentee serves as the lifeblood of scientific progress, ensuring the continuity of knowledge and the perpetuation of best practices. This is what I have dedicated much of my time to do at Godfrey Okoye University, with the initiation of the Future Faculty Program, which commenced in October 2023 during my time here as a 2023 Carnegie African Diaspora Fellow. Why choose a university to discuss this important theme? In the words of Professor Christian Eneke, the Vice Chancellor, I paraphrase, the university is associated with certain ideas: freedom of discussion, freedom to inquire, freedom to interrogate, freedom to think, to innovate, and freedom to teach. Therefore, to effectively discuss GM food safety stewardship, hands-on laboratory experience must then assume the added significance. This is because it empowers scientists to conduct rigorous risk assessments, to discern potential hazards, and to implement robust safety protocols. It imbues them with the confidence to navigate the complexities of regulatory compliance, ensuring that GM foods are subjected to the most stringent standards of scrutiny before they ever reach the dinner table. But perhaps most importantly, hands-on laboratory experience engenders a spirit of inquiry and discovery, inspiring a new generation of scientists to push the boundaries of possibilities and to chart bold new frontiers in biotechnology. It is this spirit of exploration, that this unquenchable thirst for knowledge, that holds the key to unlocking the full potential of genetic modification in the service of mankind. As we gather here today, let us reaffirm our commitment to fostering a culture of excellence in biotechnological education and research. Let us double our efforts to provide aspiring scientists with the resources and opportunities they need to thrive in the laboratory and beyond. And let us never lose the sight of the profound responsibility that accompanies our stewardship of GM food safety, a responsibility to uphold the highest standards of scientific integrity and public trust. In closing, let us heed the words of Louis Pasteur, who famously remarked, In the fields of observation, chance favors only the prepared mind. Let us prepare ourselves through hands-on laboratory experience and unwavering dedication to confront the challenges and seize the opportunities that lie ahead in a noble pursuit of genetically modified food safety stewardship. The Game Learning Center Nigeria and Norfolk University is open to collaborations and extensive partnership to make this happen. Once again, I welcome you all and wish us successful deliberations and discussions. Professor George Ube, Director of Game Learning Center Nigeria.
Thank you very much. A big round of applause for him. Okay, before we continue with remarks from other agencies, I would like to bring up the DG CEO, Professor Abdullahi Mustafa, the DG National Biotechnology Research and Development Agency, for his opening remarks. You can go ahead, sir.
Abraham, can you check my?
So we can hear you very clearly, but the video is not switched on. I think you need to enable your video. Okay, sir, we can see you very well now, and we can also hear you once you speak. Prof, we can hear you clearly. You can go on.
Can you hear me now?
Yes, Prof, we can hear you clearly.
Okay, thank you very much. Yeah, we have what we are saying that we other people okay, they are strong, and have and can you hear me?
While we I wait to the DG, I think you can take Professor Sylvia or anybody online who is also ready for it. These are good way.
Okay, Ibrahim, I don't think we have anybody online. So for the next remark, I would like to invite the Country Coordinator Program for Biosafety Systems, PBS, Dr. Matthew Dog, for his remark. A round of applause for him.
Mr. Vice Chancellor, sir, as they used to say it in those days. I'm very
continues to threaten
keep awake, because somebody who is over there talking 6 hours difference should be very, very experienced. So try and prepare your questions for the interactions that are going to come up today. There are many people on the high table here. Someone like Professor Ubi. Professor Ubi has a lot of international reach. He's a good counselor. Prepare your questions for interaction from the neighboring states, just east of here. The representative of the DG is also here from NDMA. These are all people that will work together. So I congratulate you all for coming to this venue today, and I wish all of you good listening and successful demonstrations. Thank you very much.
Thank you very much, sir. This is also to let you know that food is not allowed in the hall, but you are allowed to take water. Thank you. Professor Sylvia, if you are set, you can have your remark now, ma'am. Okay, she's here.
Yeah, I'm here. Do I have the floor?
We can hear you clearly.
Okay. Thank you very much. The Vice Chancellor, Godfrey Okoye University, Reverend Professor Christian Anyeke, adequately and ably represented. Director General of NAFDA, Professor Abdullahi Mustafa, Director of Agric Biotechnology in NAFDA, Dr. Rose Gidado, the head of OFAB, Mrs. Sarah Iwajunwa, Chair of Local Organization, Dr. Christy Onye, Country Rep of PBS, Dr. Matthew Doe, stakeholders of biotechnology and biosafety in the Southeast, ladies and gentlemen of the press, distinguished ladies and gentlemen. I bring greetings from the Biotechnology Society of Nigeria, a learned society of scientists interested in modern biotechnology. I am delighted and honored to be here today to join in confirming to our farmers in the Southeast the safety of GM crops that have been commercialized in Nigeria so far. I congratulate the organizers of the workshop, IBFRI PBS, OFAB, NAFDA, and GoUni, and I commend them for the work well done. The creation and awareness of the huge benefits of GM crops and education on the safety of approved products has been undertaken by OFAB and PBS for a long time now, and we commend them for this wonderful job they've been doing in the country. And we hope that this will remain a continuous thing in Nigeria for at least the next few years. We want to remind everyone present that genetically modified crops that are approved have the huge advantage of increasing farmers' yield, reducing the amount of chemicals they have to apply on their crops, make the food they grow safer and more nutritious for the consumer, protects them and their family from harmful pesticides, reduces the labor required on their farms, and protects the environment. Most importantly, the GM foods undergo rigorous tests by regulating authorities such as MBMA to ensure that these foods are safe for human health and for the environment. The Federal University, Oye-Ekiti, was privileged to organize a workshop similar to this last year for the farmers of the Southwest. During the conference, we were able to answer all their questions to their satisfaction, except one, which was, where are the seeds? The farmers challenged us that we convince them about genetically modified crops and foods, and they are eager to plant these GM crops, but cannot find the seeds to buy, to use. So the Biotechnology Society of Nigeria today joins the farmers to ask, where are the seeds we've been talking about for so many years? So the farmers did not just say, where are the seeds? They have profiled a solution. And they said, why don't you allow us to assist in multiplying the seeds so that everybody gets some to plant? So on this note, we want to appeal to all the authorities responsible, NAFDA, National Seed Council, to assist the farmers solve this problem of availability of genetically modified crops approved in Nigeria for planting. The planting season is very close. and the farmers want BT cowpea, teller maize, and BT cotton for planting in this coming planting season. Availability of these seeds for farmers in all parts of the country will give teeth to workshops such as these so that our farmers do not say it's talk, talk, talk all the time. So on this note, I would like to wish the participants and organizers a wonderful workshop. By the end of this workshop, we shall know what the farmers from the Southeast are saying. Thank you very much.
Thank you very much, Prof. Really appreciate it. I would like also to call my DG CEO. Can I hear you? All right, so let's move to the second part. Thank you. All right, I also want to call the representative of MBMA, Mrs. Bello Scholastica, to give us a remark. A round of applause for her.
The representative of the VC, members of the debated table, participants, students, gentlemen of the press, good morning. Good morning. Are we hungry? Good morning. I am standing in on behalf of my DGCO, Mrs. Agnes Asabara. She is unavoidably absent. She is in another program. She sends a warm greeting. We are the regulators of modern biotechnology, and as regulators, our duty is to ensure the safety of everything, right from what happens in the lab to when it gets consumed. We are very happy about this gathering. We are happy to be here. We are here to answer as much questions as possible. And we do hope that by the time we all leave here, we'll be much more enlightened. Modern biotechnology, it's nothing really without biosafety. Neither will the scientists that are practicing the technology be happy, because whatever they produce will not be accepted out there. Nor is he or she that wants to sponsor biotechnology, as it were, be happy. And the government too will not even be happy. The government has established a lot of institutes here and there. The government that went ahead to put in place NDMA to ensure its safety. If these things are not being adopted, nobody will be happy. The world has advanced. GMO, we keep talking about genetically modified organisms in Nigeria, but currently what everybody is talking about is gene editing. Nigeria cannot afford to be an as-being society. I'm particularly happy with what is happening in this university. Having listened to the VC yesterday, I want to congratulate students and lecturers of this university. You truly are forerunners. And one thing that really impressed was the airplane that I saw on the VC's table. It sends a message to me, a university that is ready to take the country to fly. I hope the students going to fly too. Thank you.
Thank you very much, ma'am. If you're talking about the safety of genetically modified organisms, you contact Mrs. Baker of Scholastica. Please, another round of applause for her. Thank you very much, ma'am. So in a moment, I would like to invite for the technical session, Dr. Amin Habora, Director of Research, Molecular Biologist, UNESCO International Center for Biotechnology, UNN. Sorry, sir, I'll call you in a while. I would like to call on my DJ for the opening remark.
Can you hear me now? Can you hear me?
So we can hear you.
Okay. I think there is a technical issue here. So we have to take it the way it has come. The Vice Chancellor of Godfrey Okoye University, the President of Biotechnology Society of Nigeria, the host, Dr. Onya, the principal officers, other invited dignitaries, ladies and gentlemen. It is my distinct pleasure to extend a warm welcome to each one of you gathered here today for the Biosafety Biotechnology Certification Workshop for Southeast Nigeria. As the Director General of National Biotechnology Research and Development Agency, it gives me great pride to see such a diverse and esteemed group of stakeholders come together to engage in meaningful dialogue and exchange knowledge on these critical issues. The Southeast region of Nigeria holds immense potential for the advancement of biotechnology and biosafety practices. And so this workshop serves as an important platform for us to collectively explore how we can harness this potential for the benefit of our nation and its people. Biotechnology holds the key to addressing some of the most pressing challenges facing agriculture, healthcare, the environment, and beyond. from enhancing crop yield and improving food security to developing innovative medical treatments and mitigating the impact of climate change. The potential applications of biotechnology are vast and far-reaching. However, it is essential that we approach the adoption and deployment of biotechnology innovation with careful consideration for biosafety and ethical consideration. As stewards of science and technology, we have a responsibility to ensure that our actions are guided by principles of safety, sustainability, and social responsibility. Through this sensitization workshop, we aim to deepen our understanding of biosafety regulations, biotechnological advancement, and their implications for Nigeria. By fostering dialogue, sharing best practices, and raising awareness, we can empower stakeholders at all levels to make informed decisions and participate meaningfully in the biotechnology revolution unfolding before us. I therefore urge each of you to actively engage in today's discussion, ask questions, and share your perspective and insight. Your contributions are invaluable to the success of this workshop and the advancement of biotechnology and biosafety in Nigeria. We are all stakeholders in Agric Biotechnology in Nigeria project. Hence, my appeal to everyone to contribute their best as we try to fashion out strategies on how to ensure that the country is food secured. I would like to express my sincere appreciation to our partners, AATF, Program for Biosafety, National Biosafety Management Agency, Godfrey Okoye University, and all those who have contributed to making this workshop possible, especially our own Dr. Obi Onya, NABDA retired director. Thank you for all the support. Let us seize this opportunity to learn, collaborate, and work together towards a future where biotechnology serves as a powerful tool for sustainable development and human being in Nigeria, and human well-being in Nigeria, Africa, and beyond. Thank you very much, and I wish you all a very productive and enlightening workshop. Thank you, and God bless.
Thank you very much, sir. We sincerely appreciate you. As you have heard from the DG, he said you should engage in today's discussion, ask questions, share your perspective and insights. Thank you very much, sir. Another round of applause for DG. So in a moment, I would like to bring to the podium for his presentation on genetic modification, its implication for food security in Nigeria, in the person of Dr. Amin Habura, Director of Research, Molecular Biologist, UNESCO International Center for Biotechnology, UNN. Please, a big round of applause for him.
we specially recognize the presence of All Farmers Association. Can you just please stand up for recognition? Thank you.
Good morning, everyone. They are still uploading my presentation, so I have 2 minutes to talk before I start. My name is Anik Kabura. I'm Director of Research of the UNESCO International Center for Biotechnology. I'm really honored and pleased to be here and contribute to these important events. My great sincere gratitude and thankfulness to the Vice Chancellor of Berkeley University for inviting me. I'm really pleased to be here with all the distinguished professors, and it's their appointment. So, my title has been detailed modified. What I'm going to talk on biotechnology, food security at the global level, and at the African level, and at the local level. Now, biotechnology now is like playing a central role. I mean, it's just the swift progress of science and astonishing advancements to tackle humanitarian crisis. I mean, particularly genetic modification strategies are becoming very critical for food and nutrition security, for human health, for tropical diseases, for bioresources conservation and utilization, for drug discoveries, for manufacturing fields. So biotechnology is now currently placed at the heart of the sustainable developmental goal, especially goal number 2, ending hunger. Goal number 3, ensuring healthy lives. And goal number 12, promoting sustainable agriculture. Next. So why biotechnology? Is it useful? And how to solve the problems using biotechnology and genetic modification. Let us look at the landscape of Africa. You see the arid and the dry Sahara. Some of the rest is forest and some of the rest is Great Sahara. And now we are experiencing climate change and global warming, which means expanding desertification, which means less water and less health. Let's just take one example, climate change. People have been talking about climate change for the last 30 years. Now, in the loop, government are spending national resources and funds to tackle climate change. The risk of something, this is not all the risk. This is what we can see just right now. There is a future projection for climate change. More drylands, hot days, hot nights, human welfare and health, reduction of agricultural production and quality, insects outbreak, wildfires, increasing desertification, declining in surface water availability, species shifts and migration. It's not only about human, it's not only about wildlife, even bacteria, viruses, and fungi are affected by climate change. To give you one example, look at this picture very carefully. This is Lake Mead in Nevada, in the United States. You see this white. You see the reduction of the water level. This since 2000 until now, Lake Mead have almost lost half of its water. And what is happening now in Nevada, in the United States, is happening in Africa, and it's happening in China and Southeast Asia. Next, please. Look at this picture carefully. This is Hoover Dam in the United States. When this dam was established in the upper picture, it was full of water. In 2003, you can see the level of water, how it goes down. Next picture, please. Look carefully, this is also Hoover Dam again, where reserve water for human welfare is stored, strategically stored for natural disasters. In 1983, almost the center tower was covered with the level of the water. In 2003, it got to half, and in 2023, it got to the bottom. This tower was filled of water when this dam was established. Now in 2023, it lost almost 80% of the water reservation. Next slide, please. Let's look at Africa and the world. In Africa, in the past 100 years, this is the rising temperatures. This is from 1,900 to 2,000. And you can see that global warming is not fabricated and it is not live. It is record and statistics and data. Next, please. Every year in the dry season, we hear about wildfire in California, wildfire in Italy, wildfire in Spain. Italy and Spain is in Europe. They don't have deserts like us. They don't have dry lands. But now, because of the climate change, the forests are drying out and they got natural disasters of wildfires. This one is especially in the United States, in Texas. This picture was taken 2011. Next, please. Next, please. So let us talk about food security and challenges, the critical challenges of the food security. There is a problem with reduction in rainfall, and there is less water level in rivers. Rivers are drying out. Climate change, rising temperatures, human water use and water waste, and demographic and economic growth, increasing population, density cities, crowded streets, from where we feel all of this ever-growing population. Next, please. Then why biotechnology? Is it useful? Biotechnology simply is that genetically modified crops are sourced with traits and phenotype have been genetically modified by taking altered DNA and inserting it into target crop. Me personally have done it many times. We work with my colleagues. We take a gene from rat, we put it in plant. In my PhD, I have developed transgenic plant for vitamin C. And this transgenic plant is having 3 times higher content for vitamin C, and you can check the publication in the literature. This is GFP transgenic mice. This is one of the first experiments to generate transgenic animals. The gene is taken from a fish, jellyfish, a glowing, a gene that makes the fish glow. The gene was taken from the fish, inserted into the mice. Now, with biotechnology, we have genetically modified a lot of crops to solve environmental stresses, biotic or abiotic stresses. We have a biotech crop for insect resistance, disease resistance, herbicide resistance, enhanced nutrients, production of medicine products. Next, please. This is one of the first genetically modified tomatoes in the United States. You know that if you go to the market and you buy tomato, if you put it in table wrongly, it will spoil like this lower picture. How to increase the shelf life of tomato? There is a specific gene that is remoted out inhibition enzyme activity which causes ripening by expression of antisense messenger RNA. This is a technique genetically modified. Now the tomato in the upper picture is having more 3 weeks longer shelf life compared to the traditional tomatoes. Next, please. This is a cheese making. Now in the United States, 80% of the cheese in the market is biotech cheese. Because you need some enzymes and protein to produce the cheese. Those enzymes are proteins in the cow and in the milk and in the cells are very, very, very small volumes. It's not enough for production of commercial level cheese. What they did, those needed proteins, they engineered it in bacteria, where they can produce it in a higher amount. Next, please. Insect-resistant BT cotton. BT stands for Bacillus thuringiensis. You know, cotton, BT maize, all BT crops. These crops are severely damaged by insects, which is called stem borers. And insects that goes inside the stem of the plant start eating the plant from inside. When they develop this cotton or maize with Bacillus thuringiensis gene, what is Bacillus thuringiensis bacteria? This bacteria is simply like this. Insects always eat the remains of the leaves of the food. When this food is contaminated with this Bacillus thuringiensis, the insects eat the food. It goes inside the stomach. This bacteria produces a toxic protein. This protein makes pores inside the stomach of the insect. When this bacteria makes pores inside the stomach of the insect starts starving. As much as the insects eat, it cannot digest the food. So what they did, they brought this Bacillus thuringiensis, this BT, they take the gene that produces the toxic protein and they insert it in the plant. And the protein is toxic only to the insect. It's not toxic to humans or other form of lives. And now, almost 90% of produced cotton around the world is genetically modified cotton from the bacteria Bacillus thuringiensis. Next, please. This is a story. They take the gene from the bacteria, they put it inside the plant, insects eat the plant. When the food grows inside, the insect's stomach is full of holes. You will starve and die. Next, please. This, you look at maize. This is a health system for BT cotton, genetically modified, and in the right hand, this is a natural cotton. Next, please. Do you hear the story of golden rice? Gold rice. The rice color is white. But now, genetically modified rice, you harvest it from the field having yellow, golden. This was genetically modified by Professor Peter Bayer from Germany, and it's published in Times magazine, one of the top newspapers around the world. What is the story? Look at the white rice and this yellow rice. The difference is that the white rice doesn't have vitamin A. It doesn't have vitamin A. Fruits like carrot, orange, tomatoes, which have orange color or yellow color, are rich in vitamin A. Then rice doesn't have vitamin A, doesn't have the precursors for vitamin A. Why? Genetically modified rice. It's very delicious and satisfactory in its white form. The reason is that, next please. Vitamin A. What is the function of vitamin A in our bodies? You see, vitamin A is very important for our vision. If your body lacks vitamin A, you got something called night blindness. You got night blind. It has function in the vision because it has some mode of action for the maintenance of your eye corona. So, contribute to the skin, bone, and tooth growth and the immunity of our health. The symptoms of deficiency of vitamin A is that night blindness, complete blindness, and impaired immunity. Who is suffering from vitamin A? It is the people in Southeast Asia because they eat rice in breakfast, rice in lunch, rice in dinner, all of your life, all of their lives, rice over rice. They don't eat a lot of vegetables to uptake vitamin A. And because of the deficiency of vitamin A in Southeast Asia, 250,000 child a year go blind. 250,000 per year, a child go blind in Southeast Asia. Worldwide, 124 billion child is deficient in vitamin A. So this genius, and this whose name is Peter Klein, what he did, he engineered the next please. He engineered the rice to have vitamin A. You know, vitamin A it consists of beta-carotene molecules. Two molecules, as shown here, of those beta-carotene, when they are attached together, they produce something precursor for production of vitamin A. Next, please. So, rice lack 4 main genes that is necessary for biosynthesis of vitamin A. It's called phytin synthase, phytin desaturase, beta-carotene desaturase, and lycopene beta-cyclase. Next, please. They brought 4 genes. They inserted in rice. Automatically, rice, when it's ready to harvest, the color changed completely to yellow rice. That is why they call it the golden rice. So you can see right now, this is just 4 genes. The genius is smart scientists. They solve a problem of 250,000 child who goes blind in Southeast Asia. Next, please. This is resistance to transgenic papaya. You know, there's some virus causes a disease called green spot disease in papaya. You know, bacterial disease, we have bactericides. Fungal disease, we have fungicide. Insect attack, we have insecticide. But have you ever heard about something called virucide? We don't have any indication for viruses. And when this disease attacked papaya, you lost all your harvest, you lost all your field. Now, 90% of papaya produced at global scale in the world is genetically modified for green spot virus. Next, please. In the lower pictures, this is genetically modified papaya. On the right hand, this is normal papaya. You can see how the field is destroyed. Next, please. Now for this disease reason, it started with papaya, but now look, canola, cantaloupes, cucumber, corn, rice, potatoes, soybean, squash, tomato, wheat. This means our menu, our food diet is all of it becoming increasingly genetically modified. Next, please. This is the picture. Okay, leaves herbicide. Look at this. This is one of my favorite slides. Look at this superpower. This is called Belgian blue. Next, please. What is it? It's like monster, right? This is the Belgian blue. Do you see this is genetically modified? Yes, it's genetically modified, but we are the human, we didn't modify it. This is natural genetic modification. This super cow, the Belgian blue, is having natural mutation. Natural mutation in a gene that it inhibits the production of something called myostatin. Myostatin. I will tell you the story. A baby, when a baby is born almost with a weight like 2 to 3 kilograms, right? But this baby, every year grows up, every year getting taller, every year he's building his muscles until he got teenager, until 19. At that age, you will stop. If you are short, you are short. If you are tall, you are tall. So by the time you reach 18, your body stops building the muscles. Biology. You can train your muscle. But if there is nothing, there should be a mechanism to stop this growing. Because if you continue growing like that, you will have 10 people. So the mechanism is that there is a gene that controls the growth of the muscle. Around 18, 19 years old, this gene works so that you stop building muscle, you do not be tired. What happened with this super cow is that naturally there was a mutation on this gene. Mutation. natural mutation. And the gene lost the function. When the gene lost the function, this sugar cow, as much as it keep growing and building up. Next, please. What they did, what they happen naturally, they discover the gene, they put it in the fish. This is trout. Look at the normal size and the modified fish. Next, please. So what is the status of this? All of these are great breakthroughs. So this is the most recent statistics of last year. You see the number of countries that are adopting genetically modified crops is ever increasing. And it reached the peak in 2022 and 2023. Next, please. Those are the countries. By the way, I got this slide from Professor Ruby. Last night in the hotel, we were talking and he showed me this slide, so I got it thanks to him. Those are the countries that are producing, adopting genetically modified crops. You see in all continents. Next slide, please. Currently, in 2023, we have more than 153 genetically modified maize. We have 66 genetically modified cotton varieties, and the trend is growing up and growing up. If we have 153 genetically modified maize, do you think that the non-modified maize will compete in the market? It will never compete. Next, please. This is the percentage of genetically modified plants approved. Cotton is 11%, maize be 45%, potatoes 8.8%, and this percentage is increasing every year. Next, please. So let's look at Nigeria. And this is a very good news about Nigeria. This is a very good news about Nigeria. Do you know that Nigeria is the first country in Africa to have a regulatory landscape for gene editing crops in Africa? The president of Nigeria in 2015, he signed the first act for the free movement of genetically modified crops in Nigeria. That was 2015. And now, in February 10, 2022, Nigeria became the first African country to put standards for the regulation of gene edited crops. And by the way, thanks to the Nigerian National Biosafety Management Agency. When Nigeria come forward, then South Africa follow. Next, please. Internationally, is a look at the green color of Nigeria. You see, the green color is mostly in the developed and poor countries. In Africa, we have only 2 or 3 countries far off. Still, at the global level, in terms of biosafety and regulation, still Nigeria is not leading only Africa, but is leading among the leading countries. Next, please. Those are the people, some of them are here, in this distinguished professor. This is 2022, when they signed, when they announced the Nigeria's National Biosafety Management Agency announced the national guidelines for gene editing and distributed printed copies of the guidelines to the public. One professor sitting was here. Next, please. So our question will be, how mother eggs feed plus 9 billion projected population by 2050? The land area of the earth is 80%. The arable land is 10%. We need 0.2 hectares per person to feed the global population. This is increasing ever demand. Our resources is not enough. Our manpower is not enough. Our water is not enough. We need much more powerful to conserve our water and to produce with less water and to fight diseases. Next, please. There's many benefits and some drawbacks of biotechnology. The benefits are proven and established. The drawbacks are still under argument. and people are fighting for us. And always the drawbacks didn't win because to win you need an evidence. You need a proof. So we have sufficient proof for the benefit of the biotech, and we lack more proofs to prove the drawbacks. But we respect the people who are talking about the drawbacks. One of the drawbacks, in my opinion, is that it's very expensive research, very expensive research in biotech crops, which is coming in the form of injustice. Poor countries, they can never ever develop these biotech crops. They will be enslaved by the rich countries who develop it and sell it to them. Also, what is about antibiotic resistance and allergy? There is no report. There is no scientific evidence, but people are worried that these genetically modified crops might cause some kind of antibiotic and drug resistance or allergies. Is there preservation of Campylobacter, preservation of species biodiversity, gene development, GM crops? And the last, in my point of view, biotechnology has come into us a new weapon, new tool to treat and to endanger the national security of the poor countries. So there's something called force feeding, using the food as political weapon. Developing countries could be faced with this force feedings. Suppose that you have a wave of drought or starvation in some African region. People run to the United Nations for aid, to the UNICEF, to the big countries, to USA. Okay, you are produce USA, produce wheat in USA is 90%. Or yes, we tell you, take this genetically modified product because they want to force you to get adapted to it. They want to force you to eat it. It's better for you to know that. When you try next time, when you want to buy, you will buy the genetically modified product. That is what we call is a political weapon food. By technology is making food as political weapon. One of the drawback. This is benefits of biotech crops, economic benefit, less pesticide used, less herbicide used, less work done by farmers, and more commercially viable products. Next is environmental benefits from smaller lands by eradicating some predators from the farms. This means you are getting the nutrients we need. Next, please. Actually, I wanted to stop here. I have only 20 minutes. But if you give me 20 days, I will continue. Thank you.
Thank you very much, sir. Before we take the next presentation, I would like us to have a group photograph.
When do you ask that question?
Okay, so instead of Dr. Egion, I would like to call on Dr. Rose Gida, the Director Agri-Biotech Department, take a presentation on breaking barriers, prejudices through science communication. Over to you, ma'am.
Ma'am, can you unmute the microphone? Ma'am, we can have you now. Okay, please, we are very sorry for that mix-up. We thought we could have Dr. Gidado because he's currently in Ghana. Dr. Gidado, would you want to have yours now? Okay, in any case, then we'll welcome Dr. Hillman for our content.
Good morning. Okay, all right, thank you. Good morning, everybody, and the VC. Please permit me to stand on the already established protocol. Good morning, and thank you so much for inviting me, Prof. I'm grateful. Thank you so much for inviting me to this workshop. So I also want to use this opportunity to bring greetings to you from my Executive Director, Professor Chibuze Egesi, who is an ardent believer in biotechnology and a promoter of the biotechnology program in Nigeria. So we're glad and happy to be here. Okay, it's my presentation. Okay, so perhaps maybe I will use this opportunity to also give our remark for the workshop. So we want to thank the Godfrey Okoye University for what they are doing in the Southeast with respect to promoting biotechnology. We actually need everybody's hand on deck to move this technology ahead. I also want to appreciate NAFDA. They do a lot. We collaborate a lot with NAFDA to get things done in biotechnology. I also want to appreciate OFAB and PBS for helping in communicating biotechnology research. So NLCRI, which is the National Root Crop Research Institute, Umudike, Nigeria, has a national mandate for the genetic improvement of root and tuber crops. So we use all available technology to produce new varieties of root and tuber crops. We also work on production. We also work on socio-economics. We also work on value addition and processing. And we also use biotechnology, modern biotechnology tools in breeding and developing new varieties of root and tuber crops that have high nutrient content, that has high yielding and other desirable attributes. Okay, so my presentation is up now. So I'm going to talk about genome editing prospects for improving root and tuber crops. So genome editing is a biotechnology tool that is also used for crop improvement. So next, please. So my third floor. Why is it talking? Okay. Next. So my third floor will be looking at. I don't have all the points to speak. So we'll be looking at root and tuber crops as the African gold mine, problems associated with root and tuber crops, how we are tackling those problems, and then we come in with the concept of genome editing, and then we also look at genome editing versus genetic engineering next. Oh God, why did I like this? Okay, so root and tuber crops, the African gold mine. So root and tuber crops are plants that produce starchy roots. Okay, so the plants that produce starchy roots, tubers, rhizome, cones, and stem. And they are referred as food security crops. And the reason for this is because they are very resilient to climate change and can adapt easily to marginal soil. So that means that if you have a little soil at your backyard, you can plant these crops and they will be able to sustain your family and also give you income at the end of the day. So they're also high in dietary fibers and bioactive components that are like the phenols and flavonoids, vitamin C's, and most of these bioactive components are what we refer to antioxidants that can actually help somebody fight against cancer. Then also they provide source of income, whether we're selling them as roots or adding value to them through processing. And again, root and tuber crops, they are drivers for a transformative bioeconomy. Everybody is preaching bioeconomy now. It is time to remove our eyes from fossil energy and begin to depend more on agri in order to provide our needs, particularly in the area of energy, in the area of pharmaceuticals and other industrial raw materials. So this is why root and tuber crops are there to our hearts and why we are working on them next. Okay, so now what are the problems of root and tuber crops? We have issues of diseases and pests, and when this happens, it reduces yield and it forces you to use a lot of chemical inputs in order to salvage your crop. So pest and disease is an issue. We also have an issue of storage. For example, like if you cite a company in the north and you want to get raw materials from the east, particularly when we're talking about cassava, that is a nightmare because if you don't get your cassava within 2 days to the site of the industry, you're going to lose your material. So storage is a big issue in root and tuber crops. We also have issues of nutrient deficiencies in most of them. Like I'll talk about cassava again because I work on cassava. Cassava is very high in calorie, but it's low in essential nutrients like vitamin A, like iron and zinc, and other essential micronutrients. Then also there's issue of planting materials because they're vegetatively propagated, and when you keep cutting the material you use this year, you want to use it next year to establish your field. As you continue to use it, it accumulates disease, and in that process, it begins to have reduction in yield. Okay, other issues, we have long breeding cycle. I have one of our very senior colleagues, Professor Kubi, he's a breeder, and he will agree with me, for you to come up with a new variety using a conventional method, we're looking at 10 to 15 years. So that's quite a long time to release new varieties. And then we have also problems of low seed sets. Please, next. Oh, next. Okay, so what have we been doing to tackle this program? So we have been using what we call hybridization breeding, or what is called the conventional breeding, whereby you get two individual parents with desirable qualities, and you begin to cross them through pollination, and in that process you get offspring. and then you begin to evaluate the offspring to look for your desired trait. So that is one method that we'll be using to tackle the problems of root and tuber crops. Then another method is what we call mutation breeding. And in mutation breeding, what you're doing is that you're exposing your materials to radiation like gamma rays. And they have the potential to induce mutation, to cause mutation, to produce a change in your planting material. So that's one method that be used. Another method is transgenic breeding, or what you call genetic engineering. You have the first speaker talk so much about genetic engineering. I'm not going to dwell so much about that again. So that's one method, transgenic breeding. And then the next method that is being used right now is what we call genome editing, and that is what I'm going to talk about, its prospects for improving root and tuber crops. So next, please. Okay, so what is the concept of genome editing? What is the idea behind genome editing? So genome editing, simply said, is rewriting the genetic information of living organisms. We're talking about microorganisms, we're talking about plants, we're talking about animals, we're talking about human beings. Rewriting the genetic information of these living organisms. For what purpose? For the purpose of, number one, to create new abilities, number two, to correct abnormalities, and then number three, to improve their performance. So I'm going to give you the underlying principle next. Okay, so we know as biologists, you understand that what makes you you, who you are, your characteristics, are all contained in what? In your DNA. The genetic information is contained in your DNA. And in the biological process, a lot of process goes on, thereby you have the transcription of the information, copying the information from your DNA into another molecule that is called RNA, and from RNA is also copied to form protein. Protein generally is what produces the phenotype. Phenotype is the physical characteristics that you're seeing. What you're seeing in me, short, I'm short, dark, those are my phenotypes. And these phenotypes are controlled by what? My genotypes. Now, example, talking about the impact of genome editing. Look at what we have by the right-hand side. That is sickle cell. How many of us have seen somebody with sickle cell anemia? All right, so you know the crisis that they can go through. So what is the problem there? So we have the normal red blood cell, and we have the sickle red blood cell. These are phenotypes. So what is responsible for this? Look at the normal red blood cell, you see the alphabet there, GAG. That's the genetic information there. For the sickled one, you see what? What are you seeing? Are we together? What are you seeing? GTG. So was it so from the beginning? No, something happened and a mutation occurred, a change occurred. So with genome editing, we are trying to go back to this sickled cell and use our biological pencil, clean the defective nucleotide there, which is T, clean it and replace it with what? A, so that it can restore back to the normal red blood cell. This is just one example in the many things that we're doing in genome editing. So that's the principle. Next, please. Okay, so there are many tools that are used to achieve this, and they include what we call the meganucleases. We have the zinc finger nuclease, we have the TALI, and we have the CRISPR. So this workshop is not for detailed explanations of these tools, but I want you to understand that these tools happen in nature. They were not manufactured in the laboratory. There are things that happen in nature, in bacteria, and in other living organisms. So what scientists will now adopt these tools and use it for the betterment of I and you. But one thing that cuts across all these tools is that, number one, they have a portion that recognizes the sequence, your DNA information, and they have a portion that cuts it. So that is what cuts across these tools. Please, next. Okay, so the mechanism, as I said, for example, if you're using, let's say you're using the CRISPR, And I said it's a tool that happens in nature, it's found in bacteria. If you're using the CRISPR, this CRISPR has a portion that recognizes, if you cast your mind back to the sickle cell example I gave. So this CRISPR has a portion that will recognize the T that is the problem in the sickled cell. Are you following? Then it also has a portion that will cause a double-stranded break, that will cause a break in the DNA strand. So, as I said, these things happen in nature. And nature has a way of repairing the break when it happens. If not, mutation is always happening around us. So nature has a way of correcting it so that organisms will not go into extinction. So also, what we're doing now is also adapt the same mechanism. After we have inserted the break at our desired position. For example, in the sickle cell example at the T. Are you following? If I have cut my DNA at the T, then I can use any piece of DNA to repair that cut. And by so doing, you will change the phenotype of the cell or the organism. So next, please. Okay, so what are the prospects if we're going to use genome editing, which is a very viable tool for the improvement of root and tuber crops? What are the prospects? What are the things that we need to have on ground? So, number one thing, it's supposed to be coming as an innovation. I don't know why everything is coming. Please go back to the first one, please. Okay, so we need to have available reference genome for most root and tuber crops. I am saying this because I understand that this is a university, and I know that you have the Department of Biotechnology, and perhaps you'll be thinking of projects that you want to do. I want to say that genome editing is a viable tool that we can use to improve root and tuber crop. But before we could do that, we need students that will work on reference genome of an organism. For example, we have reference genome of cassava and even resequenced genome, and then we have for yam, we have for taro, we have for potato and sweet potato. But we need people to do bioinformatics and study this reference genome. Where do I find this? What does this gene do? We need to have all this background information before we can comfortably begin to use genome editing to improve our root and tuber crops. We also need to increase the number of targets. For example, now, everybody is screaming genome editing. But to tell you the truth, genome editing cannot do everything. Why? Because we have not found so many targets in our different crops. So as a student, I want to challenge you today. You want to think about a seminar you want to think about a project. Begin to think, how can I develop targets? Targets for genome editing. You will say, what I mean by targets? You will say, this particular gene is responsible for this in this crop. So that somebody somewhere will say, if this gene is responsible for this, then can I change it in order to produce a new organism that have a new ability? Okay, so another thing we need is integrating multidisciplinary approaches to identify targets that both their potential for beneficial agronomic traits and suitable for genome editing. I think I've talked about that. So next, please. Next. So another thing we need to make it viable is that we need to develop plant transformation system. We are talking about, this conference is about genetic modification. So we need to have ability to transform our plants. We need to have a protocol that is standard, a protocol that is standing, so that we can easily develop these crops within a short period of time using genome editing. And then also, next please, next. Okay, so I want to briefly tell you what we're doing with genome editing in cassava. So if you look at the picture that you see there, that is a field that is affected with cassava bacterial blight disease. The truth is that cassava bacterial blight is sporadic. It comes when it wants to come. We do not understand why if we are going to have CBD this month, this year. We don't know how it's going to come, but it just happens. But when it happens, look at what, if you can see the field there, that is the kind of thing you see, a great devastation in your field. You don't see any vegetative material, and when you harvest, you don't see any crop underneath. So we began to think, what can we do? What can we do? Please, can you go back? What can we do to solve this problem? So from previous studies, we discovered that the organism, prosthetic organism, is a bacteria that is called Xanthomonas azonopodes PV manihotis. And what it does is that when it attaches to cassava, it releases some chemical that goes to the nucleus of the cell and begin to induce the cell to produce sugar. When it produces sugar, it helps bacteria to proliferate. It helps the bacteria to multiply and cause infection. Therefore, we say that this gene that is being induced is a susceptibility gene. So in other words, it becomes a target. It becomes a target for modification or for genome editing. So if you look at by the right, that is the sequence and that is the target that we now said, okay, let us knock this thing out. Let us use one of the genome editing tools to knock it out and see if you can produce a resistant material. Please, next. Okay, so our goal, okay, I said our goal was to knock out that particular gene that is helping the bacteria to multiply. If we take it away, when the bacteria comes, it will have no help to multiply. So what we did, we developed a construct and we delivered it into cassava. Next, please. Next. Okay, so our result, if you could look at the pink area, if you look at the pink area on the drawing, on the sequence, you can see empty places in the sequence. So those are the areas that we have knocked out, that we use the genome editing tool to knock out. And then, after we had produced that, we were able to recover 2 lines that when we infected them with the bacteria, we saw that the 2 lines were resistant. That means they did not succumb to the infection. Next, please. Next. Okay, so we also use the technology to develop a disease model that can help us study the disease when it begins, how it is progressing, and how it causes infection. Next. Okay, so what is the difference between genetic engineering and genome editing? So in genetic engineering, genes are introduced from outside the target organism. We had the first speaker talk about taking gene from animal and then putting it into bacteria, or you put it into plants. Then the transgene could be integrated anywhere. So you don't really follow it to know where it is going to integrate. Then for genome editing, it's all about cutting and repairing. And then it happens at targeted and specific sites. Next, please. Okay, so I want to say thank you to NAFDA, to OFA, to PDS, and to all partners. Thank you so much for listening.
Thank you very much for that presentation. I think at the moment, we're going to take a group photograph before the tea break, and we'll continue the session. Thank you very much.
Yes, let us sit down. Yes, please.
Please, would you also try to take a photograph of online participants? To take their picture.
That's what the stand here. All the students, stand up and stand behind it. For the group photograph.
Sorry.
Abraham, come and take the photograph quickly. Okay. How are you taking the photograph? Abraham, the group photograph.
Sun has risen for Nigeria, and indeed the entire country. And I hear the same old chant, the chant of exodus from the city where hunger, starvation, and death held the sway. To bring this chant to all, I shall say a word of revelation. To the farmer who mourns year by year for his labor in the farm that has become like drops of water on the mountain top which disappear at the heat. To the farmer who at the sound of rain should rejoice but rather crouched, for though harvest brings joy, the worms that eat up the crops visit before harvest. We have a chant, a chant of joy. Our sun has risen, and we not but
Yeah, for the tea break, we are going outside to take the tea break. Up there, please.
We're not allowed to eat here.
We are not allowed to eat in the hall. Please take place. Thank you very much. We're going to make it as brief as possible because we have our online presenters ready to take their presentation. So please, let's make it brief. Thank you.
sounds that good science has given us new technology. A transgenic weapon to tackle low crop yield, climate change, insect attacks, and deliver bumper harvest. modern biotech Here is my story. Over the years, food insecurity remains one of the major problems of modern Africa, where famine continues to threaten peace and stability in the mostly agrarian continent. The world is also facing a challenge on how to feed 9 billion people by 2050 without increasing the global temperature. African agriculture is characterized by insect and pest attacks leading to overdependence on insecticides and other chemicals which damage the environment and health. Productivity in sub-Saharan smallholder agriculture is extremely low to shortage of inputs, lack of access to investment, and reliance on unimproved seed varieties. No nation has been able to develop without integrating science and technology into its development agenda, and that is the path Nigeria has chosen to follow. When technology is Bio the sun
Abraham, remove the video now. I'm trying to see if I can share.
Okay, my rules.
So I have this slide. I don't know, it's by the side. I don't know where. Let me just double click on it. Is not coming on as. Let me still go back to present. Share screen. Share screen. The presentation is just by the side near my picture.
But I can share for you.
And the thing is that you may not run it the way I want to run. Are you the one sharing now?
Yes, I'm sharing for you now, so I can control from here.
But you may not run it the way I want it to, God.
Ma, can you try to share?
But I'm running it to. I can control, yes. Yeah,
yes.
That is good. Yeah.
I can see you very clearly. Very clearly.
Okay, all right.
Let me snap the computer screen.
Okay. All right. Yeah, it's on PowerPoint mode. Abraham.
Ma, you can start now. You can start.
Uh, okay, are you all there? Is the hall ready? Hello? Are you guys hearing me? Abraham? Hello? Can you hear me? I just want to confirm before I start that everyone hears me. Hello? Good afternoon, everyone. I want to ensure that everyone hears me before I continue. Abraham, can you hear me? Good afternoon, everyone. The Vice Chancellor, Godfrey University, and other dignitaries that we have here. My boss, Dr. Onya, the NBMA DG, ably represented by Scholastica, the coordinator, PBS Nigeria, Dr. Do, Chinyere, and all the OFAP team that are there. It's nice having you and all our stakeholders at Enugu, our farmers, civil society organizations, and all other biotech experts, the former President, Biotechnology Society of Nigeria, Professor Ben Obi, and all our friends that are there in Enugu. I'm sorry I couldn't make it physically, but at least I'm here presenting online. I'm actually presently in Accra attending annual and review meeting of pod borer resistant cowpea project. We're trying to strategize on how best to serve our farmers to add more value to what is already there so that farmers can maximize their benefits. So I'm here for actually a very important workshop review meeting. It's nice to be in Enugu again. This is like either the fourth time of us being in the Southeast, and which is very, important as we strive to improve agricultural productivity to ensure food security and environmental protection. It's essential that we address concerns and misconceptions surrounding biotech, through open dialogue, scientific evidence, collaborative efforts. We can actually work together to promote a culture of biosafety and responsible innovation. So in my presentation today, I'll actually be sharing with you what we had to go through to have the pod borer resistant cowpea commercialized in Nigeria and other GM crops as well. We presently have like 3 crops commercialized, and with farmers access, that's cotton and cowpea. The tailor maize is just recently commercialized, and we're trying to see how farmers can have access to those seeds. So we had to break a lot of, barriers of prejudices, through science communication. So I will share with you the case study for pod borer resistant cowpea. So science communication is crucial for breaking down prejudices and misconceptions about scientific innovations. So the pod borer is a genetically modified crop that has faced public skepticism and resistance. The technology was actually developed by scientists at Institute for Agricultural Research, Zaria, a team of Nigerian scientists and all. And so NABDA was actually in charge of the communication component. We bore most of the communication aspect, which is very crucial. In any scientific project, you must have a communication component. So this presentation will actually explore how science communication can actually help address concerns and then promote adoption. So if you may ask, like maybe some of you would not know, what is pod borer resistant cowpea? Is a cowpea that has been genetically engineered to resist the pod borer resistant, the pod borer insect. The pod borer insect is maruca, is what is called maruca. Maruca is the butterfly, is the insect larva of that maruca. If you plant cowpea and it germinates, begins to form leaves and flowers and what and pods, those larvae come and they eat everything off, and the farmer has nothing. Sometimes the farmer can have even 90 to 100% loss, So it has the potential to increase yields, actually, this PBR cowpea, and improve livelihoods for smallholder farmers. It's developed through a collaborative research. AATF is actually the main funder of these projects, and IAR in charge of the technology development, and so on and so forth. So the common, what am I seeing here? So the common concerns, at least we have in the context of PBR copy, we have common prejudices and misconceptions. And these misconceptions, of course, they include beliefs that GM crops are harmful to human health, and then concerns about environmental impact, contamination of traditional crops, assumption that PBR copy is a foreign technology that will lead to dependence, on the dependence on technology that has been imported. So we have misconceptions about the safety and so many other things. I think some of these issues were actually highlighted in the presenter from UNESCO Center for Biotechnology. I think I saw it online. So those common concerns is all mostly about health and environmental impacts, and then contamination of maybe food sovereignty, I think. Yeah. So misconceptions of PBR is quite, on the increase, every day, because of the success stories that we have. So, and it's important to address some of these prejudices through science communication education, and that was exactly what we did. We provided information, we did a lot of information sharing, scientific facts, sharing the knowledge and then networking, building trust, and promoting understanding, between amongst the public and all. So you may ask, what is science communication? It's actually a process that involves the sharing of information, wonderment, and the raising awareness, on science-related issues, of course. And communication between the scientists and the public is very crucial, especially about our scientific researches. It's, from the scientists to the public. And it is actually not complete, not effective, until the public receives that information and the information gets through the public and they understand. And then there's an impact. You are giving out. As you're giving out, it must go through. If it doesn't go through, you've not done anything. So it's actually communication, information sharing and communication. They're actually science communication. They're two different things. In information sharing, you're just sharing. You're not sure whether it's been uptaken. So, and then science communication, we also have to know that it is not about selling our science products, but it is about putting science into use by helping the public to understand research results and make informed decisions. So without communicating effectively, some of those products, at the end of the day, if you produce them and people don't really understand, the uptake will not be there. by the public, by the consumers. So it's actually about telling your own story, science communication. If you don't do it, others will do it for you. If you don't tell your stories, you start a project without communication components, then you are bound to fail. It will be dead on arrival. People need to understand what you're doing, what you're producing, or what you have developed. So, and these are the dangers of misinformation. If you don't tell the story, we have others, the environmental activists are there to tell the story for you, and the way they will do it, they will misinform the people, carrying negative, contradictory information about what you're doing. And so this is what we actually experienced. Protest, and they do it in many ways: media campaigns, petitions, court cases. We went through court cases, went through a lot: social media engagement, one-on-one engagement, protests like this. I think this was carried out in Nigeria, march against GMOs and all. So, and then this is a Punch newspaper publication. I think when PBR copy was approved, for environmental release or commercial release. So they went on a rampage. They published a lot. They did a lot of editorials and all, just to cause panic and fear in the minds of people that PBR copy can cause cancer, it can damage the environment and all those things. So we had to build strategies, we had to do a lot. We had to go out of the box to do a lot of things, to repose confidence in people and to tell them it's a science, this is a science venture. It's based on science. Whatever we're doing is based on science. So these are some of the strategies: clear and simple messaging about the benefits and risk of, we did a lot of that. Engagement, well, sometimes we just say risk, but there are potential risks, but the risks are not really. When the scientists are working, they ensure that those risks, if there are at all, there are measures in place to avoid, those things happening. So engagement with local communities and farmers, addressing concerns and building trust, use of local languages, we did all. Media channels to reach a wider audience, involvement of local scientists and experts to build credibility and all. So the trust challenge, building trust is actually a big challenge in this business. So we had to build a lot of trust and credibility. People want to know that you care before they care about what you want them to know. You know what you know, and when you want them to. So in this case, there is what we call empathy. Listening, caring. You have to listen. Maybe the things they have, those concerns, some of them are genuine concerns, and it's to keep you in check so that you do the right thing. You take care of all those safety measures. If there are risks, of course, you come against those risks. You find measures how to address those risks, and then you have to communicate. So, and you have to, who do your stakeholders trust most? So you have to do a lot of stakeholder mapping, look out for groups, stakeholder groups that that people trust most, and you identify with them and educate them and what because when they talk to people, people will listen. So we had to do a lot of that. So the case study now for Nigeria, this is the PBR copy case study. I'm giving you this as an example to see what those things that we went through, all the strategies that we put in place to ensure that the approval for environmental release, the approval for commercialization, and all those, were actually successful. We were able to deal with those those issues. So PBR copy was approved for commercialization in 2019. For environmental release, same 2019, January, by December, it was approved for commercialization by the Varietal Release Committee. So science communication strategies adopted included farmer field days, radio broadcasts, community meetings, and the results showed increase in adoption, copy adoption rate. So we did some of the activities carried out: seminars, workshop, tour of select media houses, targeted capacity, documentary production. Seeing is believing tours, because when people see, they believe. Because what if you just listen to the antis, they will tell you that if you plant a GM crop here, that no any other crop will survive, and you won't even see any insect, and that is lie. All those, as we had them on our field, we established demonstration plots at NABDA and in other places, and people came, the media visited, and they even saw even ants were on those crops. So farmers field days, production and dissemination of information materials, all were done: radio jingles, TV jingles, radio programs, social media posts. There was nothing we didn't do. So, like, we broke down the activities. We had what we call pre-activities, that is pre-approval activities. And we started with our ministers. Of course, then the Minister of Environment was Amina, who is now the Deputy UN at the US. So we had the Minister of Science and Tech as Dr. Ogbonna Onu, who is of blessed memory now. And we had the Minister of Agri, Audu. I think at the beginning we had it very rough with them because they didn't understand, and they were inundated with a lot of contradictory information from people. So they were boxed left, right, and center. And so we had a lot of issues. We had to pay visits to them constant. And after every discussion, how do we do as if he understood what we were saying, but at the end, the next day, what you will see on the newspaper will be something different. So we took time anyway, but I think at the end of the day, we achieved our aim. We got them. How do we got converted when he saw the BT cotton on the field? And he was so happy, so impressed. So engagement with the high-level policymakers. Yeah, this was one other meeting again. We had to go with the Biotech Society of Nigeria group, our experts, some of our professional bodies, the Genetic Society, where they were all involved. We had to just come together, as stakeholders and this business as partners, as what we had to put up highly spirited fights, and then we got united, as one, and we actually had it, through. So this was a farmers field day, at Zamfara State, when the cowpea was actually before the commercialization and all. Social media engagement at that particular time. This is documentary production. We had to raise up a media team to go to IAR on the field there, interview those scientists that really developed. The scientists were led by Professor Ishaku Mohammed, who is the principal investigator of the project. So the documentaries were actually aired, we bought airtime at TV stations, different TV stations, and were aired most of the time. So a lot of media engagements here and all media management. Actually, the platform we used most of the time was the OFAB, the Open Forum on Agri-Biotech in Africa, Nigeria chapter platform. And so we had members from different, agri institutions that were carrying research on some of these projects. But NABDA is the host of OFAP in Nigeria. And so through OFAP, we had a lot of some of these programs, media programs, that actually targeted 50 million Nigerians from 6 geopolitical zones that were engaged and educated. A lot just went through, we did quite a lot. These are video links. If you have access to this presentation, you can actually play some of these video links. We did a tour to media houses in Abuja. That was another, strategy, visiting the managerial teams in each media house, both print, radio, and television media houses. We had to go into dialogue, one-on-one, because some people don't really when is lack of information for some people. If they have the right information, they're okay. Some have already maybe made up their minds, but some, if you educate, give them the proper education, and the media is actually the best to partner with, because it gives, once you get their buy-in and what, it has a multiplying effect, because they reach out even to the grassroots, to the villages, especially radio. So the media tour was to actually discuss with the managerial team, like I had said, inform, and they will, further inform the government on position of the technology, give briefs, seek ways of collaboration and all. So these pictures are actually pictures from visits to the media houses, NTA, and some other print media houses, and we had quotes from them. Yeah, many of them were gladdened, their hearts were gladdened that we had reached out to them, and they took us very seriously. So we have some of these responses here. If you have access to this presentation, you can actually go through it. Some outcomes from the media houses that we visited. Biotech, we had another program on NTA that actually ran for, a quarter, about 3-4 times, and a quarter has like 13 weeks. So it was really, really an intensive campaign that we did. So we got ministerial endorsements at the end of the day. We got our ministers convinced and all. And the former Minister of Science, who is now late, had to say that anyone who says GM technology is hazardous to humans should provide scientific evidence. Yeah, that is it. And then Audrey said, we won't run away from GMO simply because we are afraid. Till date, we have not seen any or heard of any evidence that GM crops are unsafe. So Audrey is still alive. Then this is now the post-release. I'm done with the pre-release activities that we had carried out. So when it was announced, yes, that approval was granted for the PBR copy, the aunties were, they were quick to book an appointment with the Minister of Environment. Their mission was to ask government to direct NBMA to retract the approval. And so we quickly actually got together and had our meeting and made our declaration, called the media, and everything was everywhere. So we had a lot of media with us. And then we also engage on commentaries, 13 weeks commentary on, at the Radio Nigeria, Federal Radio Corporation, and which addressed concerns on the safety of PBR copy, targeting policymakers, lawmakers, civil society groups, media, consumer groups, and all. And we had topics, treated for each commentary. It was a commentary were usually Mondays, I think. So, and then we also had communicating to the grassroots using local languages. Yeah, we did Yoruba, Igbo, Pidgin, English, Hausa, and they were played in different, I think, all the geopolitical zones. I think the Southeast was played in Enugu, a radio station in Enugu. The Yoruba was in Osun State, and then the Hausa, I think, around Kaduna, Kano. So a lot of engagements that we had to do, out of the box. So, and then the print media was not left out. We also engaged them, editorials, opinion, and all those stuff. These pictures actually speak. We did adverts as well in some of the print, the national dailies. So commercial release of Podbora cowpea here, first GMO crop, actually the Podbora cowpea is the first first GM beans in the world is not anywhere, only in Nigeria. And I think Ghana will be the second. We're waiting for Ghana to also release their own, commercially. But they've granted environmental release to it. So these are like social media engagements: Facebook, Instagram, LinkedIn, YouTube was not left out. And so me, I hope everyone is hearing me. I'm just reading. I'm not getting any feeler that I'm being heard. So lessons learned here. Science communication is key to addressing prejudices and misconceptions, and the anti-technology claims are over-exaggerated, and more should be done to dull their noise, actually. The scientists in Nigeria, that the biotechnology and biosafety stakeholders, we need to form a very strong team. We need to come together, amplify our voices, reach out to people, network, do a lot. So policymakers are actually supporting us. We've got a lot of endorsements, even with the present ministers that we have. We had an engagement with them recently, and it was really wow. So policymakers can be more supportive through constant engagement, and the National Assembly too. I think they're the next targets that we're having. So children and youth are a sustainable force towards promoting awareness of this technology. Secondary schools, yeah, I think those days we used to go to secondary schools, catch them young is actually the best, because they will go educate their parents, educate their sisters, educate their friends, and when they'll grow up with positive, notion about this technology, not negative. Because we have, like the universities now, most universities have biotech courses. They have centers of biotech, they have departments and then you're training students. So it's not really good for the students to now, they've gone to school. Once they graduate, they need to work, and they need to work where they can actually practice their profession. And so we need to put up highly spirited. We need to do this together, amplify our voices, come, build a very strong team. So engage with local communities. Engagement with local communities and farmers is also very crucial in building trust and credibility. And I think the NBMA needs to work very hard in this endeavor, and they need to establish laboratories, good systems, and what. Clear and simple messaging is also essential for each group of the society, and then for effective communication, and then fun activities like drama, quiz, games to enhance better understanding. I think that's, yeah, once in a while we carry those things out in our OFAP programs. So as we move forward, towards consumer uptake of the PBR copy, we need to focus our attention on the following: use community radios more to talk to the people in a language they understand, and then produce more flyers, for insert into the list too, explaining the benefits and the level of the PBR copy. The universities can actually join us in this crusades. They need to also help. They need to create maybe form communication groups from the social media and what different communication groups. And the need for town hall meetings in the various geopolitical zones of the country, and they recruit select ambassadors for the PBR copy, target more radio and television programs whose audience are mainly market women and farmers, and the participation in the national agri shows. So the conclusion here is that PBR copy is a valuable innovation that can improve livelihoods for smallholder farmers. The target, actually, the smallholder farmers are our target, how we can transform their lives, how we can improve their lives. And so science communication can help break down barriers of prejudices and promote adoption, and acceptance by consumers, because consumers now, we're facing consumers, we need their buy-in because if there's no market for it, the farmer would stop using it. But the farmers are okay because their yields are better. Better yields. The potential yield for cowpea, PBR cowpea, is 2.9 tons per hectare, while the local one will actually give you only 250 kg because of insect damage and all. So we must continue to engage with local communities and farmers to build trust and promote sustainable agri practices. So acknowledgements, yeah, ATF, PBS, of course, PBS has to be here because they're the main sponsors of this very biotech and biosafety workshop done in Enugu and some other parts of the country. They contribute a lot to what OFAP is doing. And then they actually contributed a lot towards putting in a biosafety process in Nigeria. When the bill was at the House of Assembly, we worked with PBS, hand in hand, even when, we didn't have products. They were there for us, technical support, and, they gave us a lot of technical and financial support, and they are still doing it. They've not left us. So appreciation to ATF, to PBS, IAR for the PBR copy, and then ARCN is the co-host of OFAP in Nigeria. NBDRA, NABDA has changed to National Biotech Research and Development Agency. And so I hope everyone has heard me, everyone is following me. Thank you so very much for hosting us once again. Enugu will continue to come. I think maybe next time we may go to Imo again, and maybe spread across the southeast and reach out to the grassroots. So we look forward to more engagement with you, especially Godfrey Okoye University, and my boss, Dr. Onya. Thank you so very much for all your commitment to ensuring that Nigeria benefits from this technology responsibly, that we practice biotech, agri-biotech responsibly, and all others. Our former president, Biotech Society of Nigeria. I know when you were president, we worked very closely. You actually helped, assisted us a lot. And the Director Center for UNESCO Biotech, I know when the process started, NAFDA contributed a lot. We had several meetings on that center when Professor Solomon was alive, and I'm happy that the center has taken up, and so we have to work closely together. Thank you all. I wish all of you very successful outing and better understanding and uptake of the technology. Bye. Bye. If you have questions later, I can address, or Abraham can address.
by now. Good afternoon. Of Southeast farmers and scientists, academia, on the issue of perception, your perception on GMO. What do you think of genetically modified organisms? Because getting a lot of negative information, and in the recent time I was wondering, is it because we want to hold this workshop in the Southeast that all this negative information has been coming up in the media? And at the time I was wondering whether I knew that this workshop is very necessary and very important. Is it online?
Yes, you can go on.
I want to see it here. You can download it.
No, it's like I was here to
So the top title is Perception about GMOs in the Southeast. The outline is what are GMOs? What are GMOs? You cannot have your perception of what you do not know about. If you don't understand the science of it, you can easily be deceived or be misinformed. Number two is promise and benefits. The director from UNN, the UNESCO rep from UNN, had already explained what the benefits are. And the third point is, what are your concerns? Some people have already mentioned it. Dr. Vidal had told you what the public, what are the concerns, and how are we addressing it? How are we managing these concerns? Number four is expectation. Okay, it's here. All right. Perceptions of GMOs in Southeast, and then conclusion. So what are GMOs? Next slide, please. Genetically modified organisms are plants, animals, microorganisms, or other products derived from modern biotechnology processes. They are organisms that have added genes to preservers, had already done that, or deleted genes for value addition. You know that something is causing problems to humans, to the environment, to the ecology, and you want to address those issues and ameliorate the problem. Next slide. So the basic processes of genetic modification, which I normally teach at second level to biotech students at second level, are the processes, the procedures. What do they do in the lab to modify an organism? It is here, you identify gene of interest, then isolate that gene of interest, amplify it, then you associate the gene with promoter or insert it into a plasmid. Then the multiplication issue comes in, you multiply it when you have already inserted it, and transference. Transfer it into study that you accept until you get the product. Until you get the product of interest. So about the concern, after you have gotten your product, people are talked about BT, cotton, cowpea, and other products we have already approved and commercialized in Nigeria. Are we accepting them? What are your concerns? Why are you not really happy with what the scientists are doing? Your concerns, are they safe for health? If we eat it, some people tell me I will never eat GM food. Even high-level scientists, microbiologists, biotechnologists themselves, some of them have not really accepted it. Are they safe? Are they environmentally sustainable? Are the seeds patentable? These are the issues. Even when farmers have accepted it, they're still querying the issue of patenting the seed. And who are the beneficiaries? I think this is the major problem for Africans. They always think that any new technological development is for the interest of the white people. They don't think we are the beneficiaries. Who are the beneficiaries? Again, who should they be labeled? So there are two issues. The fear that, of the public. This GM is not good. We are not going to have it. After you have invested so much in developing the product, I know when we started the BT cowpea, it was more than 15 years. I remember when the man from Australia came into Nigeria to talk about this gene that can improve cowpea. It's more than 15 years now. Now that it's just being commercialized, are we still accepting it? Have we really fully accepted it? To me, there is a need for cowpea because even the exported cowpea still has issues. Exported cowpea from Ghana that I saw in the UK, the wiggles are still there. If you get it within 2 weeks, you see some wiggle coming out of it. So how do we address it? It's about this communication that we're having. Dr. Igalo had talked about the importance of communication. We have to discuss with the farmers. The farmers have to be enlightened before they can really join scientists to take it out from the lab to the field. Are we knowledgeable about it? That's what the lady from NRCR talked about. She had the knowledge, what had gone into cassava. I remember when cassava had a problem. Some of you were not born that time, some of our students. We had a cassava virus that nearly wiped off all our cassava. The scientists kept working, and today our cassava, you can harvest it and keep it in your house, and you harvest, the product has been improved, and they are good. So the virus has been wiped off. It's about knowledge, and then facts and figures, which we are giving you today. These facts and figures made me to think about that designing a questionnaire to know what you people think about GMO. We are going to give you the result of what that questionnaire, the outcome of that questionnaire. Next slide. Okay, next one. So the promise, Dr. Habora talked about the benefits, using less land, less water, less energy, fewer chemicals, less land, less waste, which is my area of expertise, more stable yields, and better means of livelihood. Next slide. It reduces poverty. The doctor had talked about it. Enhance food security, strengthen rural economies, increase international trade competitiveness. This is our own problem. We cannot see, I was in UK for some time, we cannot see our product in the market because of this international trade competitiveness. If your product is not good enough, the cowpea from Ghana, I don't know what is happening to Ghana cowpea. It's always wiggle rigging, and people avoid it. But people like cowpea. Other countries do not have the product, but because we haven't really produced cowpeas that are safe, that are not infested with insects. It cannot, the storage is very important. You cannot store it for more than 2 weeks before it's all ridden with weevils. Increase GDP. If you have international trade, if you are competitively, internationally, viable, your GDP will increase. Conservation of foreign exchange, industrialization, job, wealth, and environmental sustainability. These are the benefits. Next slide. So some of the GM products already commercialized, they're all here. We have only few in Nigeria, which other presenters have talked about, and we want more to be commercialized if we accept the products. Next slide. And more discoveries are coming up. We're talking about as the Iboman presented, the gene editing. With gene editing, we will have more products. People accept it when it's human that is being treated with that kind of technology. But when it's plants or other organisms, lower organisms, they query it. But if you have a sickle cell, for instance, you will pay anything for your daughter or your son to be healed, no matter the technology that is being applied. Next. So what are the issues, the concerns? It's based on perception. It's not a science. It's not scientifically proven that these fears are proven. It's just perception. It's ordinary fear. It's hearsay, what they read on WhatsApp. Recently, a lot of information has been flying up and down on WhatsApp and putting fears on people. Sometimes the interpretation of the research is even misinterpreted. Next slide. Okay. Many farmers are now indebted. They think that what I used to hear that even made Monsanto to keep quiet in Africa is what information they are spreading all over about Monsanto, that they are just hitting us to make money. In fact, some people will say that they will kill us with what they are bringing out as products. So the pressure on Africa to adopt uniform seed laws. There was a time we want all African countries to adopt uniform seed laws, and farmers were not very happy with it. The Nigeria's biosafety law that is signed into law, or bill signed into law, is weak. These are their concerns. And recently, they said that Burkina Faso stopped planting BT cotton. I don't know their reason for it, but all these things are fears, and they cannot stop the science to go forward. Continue. The GMOs have destroyed. They are thinking, the doctor had proven that biotechnology improves the soil because we are now using less chemical fertilizers. We are using animal manure and all those things that we can produce with biotechnology. The adoption of genetically modified and chemical fertilizer by African nations has been described as suicidal. These are their perceptions. We talked about Bessie. I was in a conference with Bessie on a debate. Eventually, he could not prove to us or to the audience that GM is suicidal. Continue. So how do we manage these public concerns? Next slide. There is need to be transparent. This is one of the reasons we are having this workshop. They have told us what happens, how these things are produced. Transparency is very important. Transparency is important. There is need to make our valuations explicit, our interest transparent, assessing the contribution of genetic engineering to fighting hunger in developing countries is not simply an academic task involving facts and figures and rational evaluation. The interpretation of data is subject to interest and value judgments of a variety of stakeholders. Everybody should be involved in developing the data and interpretation of data through communication. Next. So, these are the concerns: adequate communication among various stakeholders with coherent messaging, which our lady here had talked about. Adequate training of farmers. Farmers should be adequately trained. We have an agronomist here. Professor Ubi can tell us how he trains farmers. Next one. Scientists in the research institute and the university should be given communication training, encouraging the training members of the different stakeholder groups to use websites. She told me something that touched my heart yesterday, that Dr. Okoye is doing a lot, but we are not well present. They are not seeing what is coming out of this university. So we should be present in the website. This could possibly lead to better management of public perceptions of GMOs. Next. Rose, I talked about newspapers, pamphlets, which OPAC normally carries about. Brochures should be continuously used to disseminate information on GMOs. Publications like this can be printed in dialects to reach more audiences Rose talked about Igbo. No, I said 4 people from each state.
The first election the first report the chief was we should send for even if we send before he was
Four from each state.
I didn't know how the people were selected.
Yes.
If they had come to me, I know those who would have been here.
Because you didn't respond to letters. All right, clap for them. Made effort. You communicated.
Yes, I communicated.
Yeah, if I knew that you were going to
Yes.
Okay, sorry about that.
No problem.
Okay, stage, please. What's your name?
Mercy, okay, okay.
And your name? Where's your husband? There's
No,
another
it's not the husband. That is Afan chairman of the second case. Chief asked, they say they are not, they are asking the same son.
The same son. Okay, give us stage, please.
We are here. We nominated 4 persons, and later they say it's only 2 that they shortlisted.
Who is saying that?
Chief told us, Chief Okafor told us that only 2 were chosen from Imo State.
Okay, we are the youth representatives. So we are the ladies. From Anambra.
Right?
Okay. Okay, thank you very much. Thank you. So, thank you, everybody.
Okay. Professor Ami says he has one question.
Are you taking questions?
Yes, we want to.
Okay, I have questions.
Actually, this is very excellent presentation, and I like it very much, and I think everybody likes it very much. And one part in the presentation that really draws my attention is that when she started the presentation by saying that some people are saying that they will never ever eat genetically modified food or crops. You know that we are as human, sometimes we are not fair ourselves, because sometimes we have something called double standard. The same person that says that I will never ever eat genetically modified crops, is he going to quit taking medicine if he got sick? Suppose this person is having diabetic, you need to take insulin injection. Is he going to refuse taking insulin injection? Do you think that the insulin that we take it for diabetes, most of antibiotics that is we take it for our sickness is recombinant? Insulin is genetically modified, is recombinant. Yes, we don't have exactly. We don't have insulin volunteers that can volunteer to donate insulin for you. Insulin is produced in our pancreas in very tiny, low, small quantities. It's very enough for our bodies, and we cannot extract it in enough quantity from animals. What they did, they took the genes and the pathway of insulin. They make it recombinant inside the bacteria, and they produce the bacteria in very large tank, and then isolate insulin, purified it, package it, give it to the hospital. So if you are refusing to take the genetically modified organism, then you are going to refuse 80% of the medicine provided in the hospital. That is why I say the misconception always coming that sometimes we are not fair to ourselves. Sometimes we have to understand that we believe it's a fact, and at the same time we believe it's the opposite of the fact. That is what I'm saying, that today or tomorrow, there will come one day that everybody will see that genetically modified organism is a guarantee for his health.
If you have taken conflict, raise your hand.
Everybody.
And then if I'm not close, there is anyone that said you will not take GMO, let us assess.
If there's anybody here that can say I will never taste GM food. Anybody? I know my nephew, the mother is here. He visited me in Abuja, and we were driving. He was hungry. He wanted corn, boiled corn. I said, okay, the person comes, and I said, okay, I picked some and gave him, and he saw it's so big. He said, oh, Auntie, this is GMO. I won't eat it. And this, that is big. You know, perception. Anything that is out of, normal is GM. This boy threw it down. People thought he was hungry. He refused to eat the corn that is GM. Today, he's a consultant doctor in UK. And he eats all these burger things. Are they not GM? Any question or addition? Okay, yeah. Okay.
Sorry, please, before you answer, why you mentioned that one place? If you are picking that, then you will pick GM.
Yeah.
No, don't deceive yourself.
I've never been.
Did you take the vaccine, the coronavirus vaccine?
Wait, Chief, go ahead. I'll bring it.
Okay.
Yeah, the next.
Okay.
Well, I think farmers are here. Great farmers,
Great nation.
no farmer,
No nation.
My name is Dr. Imran.
Okay.
I'm from Imo State, the state chairman of All Farmers Association of Nigeria. Imo State chairman. My concern, I have some concerns about GMO.
Okay.
I started attending workshops on this GMO more than 10 years ago. The University of Nigeria, and so that some professors were asked to make some presentation, and they invited farmers more than 10 years ago. And it appears we are still the same place.
Exactly.
The question farmers asked 10 years ago is still the same question we're asking today. Where are the seeds? Why are they not labeled? How do we identify GM crops or even livestock? What is playing out now is that if you have a broiler that is very robust, they say it's GMO. If you have a maize corn that is very big and robust, it's GMO. Why can't we label these things and be sure what is what, and how do we identify the one that is GMO or GMO engineered or the one that is ordinary? There's a lot of confusions in the market. And now, somebody told us here today a good story, how they started, how the policy makers were sensitized. He mentioned that we obey the minister then and so on. And he did not take it down. I didn't hear saying we also came down to governors, to commissioners, to some policy makers. Because I don't see the essence of the regulatory body. If actually all the good things he said about the advantages of GMO, if they are there, government is supposed to, open door for it to come in. Why still the suspicion more than 20 years? We're still suspecting it is not good, it is good. Why is it like that? First of all, I think the policymakers should be sensitized and they should be, how do I put it? They should now know. Since there's no scientific proof that GMO crops are dangerous to them, why is the government still setting standards, setting a regulatory body to limit it? We are confused. If actually there is no scientific proof that this particular product is dangerous to the body, why is government still regulating it? Why is there a regulating body who is now regulating which one to come in or which one? Which means it is now increasing our suspicion that this product is not very safe. Thank you very much.
Why would you ask that question? Let me add, this transparency that we did in the beginning of this, we want to talk, the last speaker talked about transparency. We are going to tell us what we want to discuss open transparency. Nothing is hidden. Don't discuss something here and just let us know what is in your mind so that we can have this interaction and then discuss it and we'll be better informed by the time you leave this video.
I've not received that.
Let me contribute. But please allow me to sit down. Have a good day. I introduced myself earlier on in the day. My name is Matthew. I am the first director of biosafety in Nigeria. I retired voluntarily in 2007. It wasn't time for me to retire, but I retired because of the things you're referring to. Now, Nigerians want what they cannot have. If you plant yam, you use fertilizer. Nigerians don't like ordinary fertilizer. Yes. Nigerians query fertilizer. If you raise catfish in concrete pond and you feed the catfish scientifically, Nigerians don't want that catfish. I was a civil servant here in Enugu long time ago. I left here in 1991. Before Jim Wobodo built the resort there, there were crocodiles, fish, and so on. The cities are expanding. I come from the Niger Delta. There's no environment in which people will kill fish. So you cannot go to any swamp in the Niger Delta and catch fish. To feed 250, 300 million people, we are not realistic. That's why I said Nigerians want what they cannot have. The garden is gone. I will send these children wearing green here to do biological sciences. The problem with us as Nigerians is we go to school, but we don't find out from secondary school what and why we are being taught certain things. I remember studying spirogyra. Anybody remember studying spirogyra here? Yes. What is spirogyra used for? Anybody knows? You know what it is, but what role, what is its use in nature? This question queries the type of education we have in this country. That is why they laugh at us that God has blessed us. It is not government. We, the sun, the rain, availability of water, these natural resources, which we don't know how to use, that is why we allowed this law. 2, 1992, we were negotiating Cartagena Protocol of Biosafety. I went to Zaria to lecture university lecturers. 2 weeks later, a lady wrote to me that she knows that I'm preparing Nigeria to receive GMOs. That is why I have come to lecture them in the university. So we did all the things we could do. 2007. Oh yeah, knows. I told them bye-bye. Let Nigeria carry on its work. But I returned to do the same job outside. So those of you who answered the questionnaire, what are the sources of your information? Those who think there's question about GMO, what is it? What triggered you to disbelieve or to have this ambiguity about GMOs? Anybody? Yes, ma'am. What is your source of distrust? What is your source of distrust?
Your source of information.
I'm not standing to say so.
So they ask questions. People who say they will not eat GMO. Why? What is your source of information? She gave a percentage. She gave a number.
Okay, we have someone here.
Yes, brother.
I have a friend that said that the white people are wicked.
Yes.
That they know that it's killing.
Yes.
They are introducing it to kill.
So let me ask you, what we should ask those people
And
is
the mic not working.
The mics are not working, sir.
I wasn't feeling well. Yeah. I wasn't feeling too well. So I went out to take Panadol, to buy Panadol. I had drank it here. So, what do you know that is inside Panadol? Huh? You said?
It's only the pharmacy.
It's when you analyze it.
So, but you drink it, you without knowing what is here. Good. My youngest child was born 1987 in UNTH. She's a lawyer now. All my children do immunization. Am I right? And every day you hear people talk about immunization. How many people here have not been immunized or did not take immunization for their children? So, if we don't trust the white man, think of the number of sources that are viable to do us harm. Are you hearing me? So, what I've said was summarized by a funny but very serious musician called what? Fela. I don't want to die. My begin too young. I never grew up for village. I never buy car. Do you people remember all those things Fela said? That is a simple reason why we don't trust whether white man or no white man. But you touch on the sore point. Why are we wasting time? Because we're always pointing. So we have 2 crops that have been approved by the Nigerian government. Those 2 crops have been developed by Nigerian professors. Nigerian professors. One is cowpea, the other one is maize. We as a people, we are not innovative. We are not innovative.
I said I left in 91. Okay, you will know. Those are places that I used to go and buy yam. I wasn't SAG, but SAG is a common thing here in the Southeast. Am I right? Yes. What is the research? I know how frequently yams in the barns get spoiled due to fungi. The leading fungus is called Theobroma. It's all over the place. What are we doing to reduce yam loss? It is the same cutting of yam. You cut it into 2 or 4 or 8 or 16, 32, isn't it? That's the same technique. It's about 1,000 years old. When Dr. Obama spoke in the morning, she was challenging the students to do bioinformatics. The Sudanese showed Papa, and just now he talked about insulin. People don't mind the source of medicine, but because they cannot choose. That is why they don't mind. When I show my slide, you see the insulin thing. But food, people like to choose. People like to choose food, but it is a false choice. Just let me round up. Can anybody tell me where Papa comes from? Papa?
They are not.
I'm speaking in Goda.
They are not.
You are translating and saying, where does it come from? Huh? Huh? You see, you don't know. I asked the same question 2 weeks ago in Kano, that is the capital of groundnut in Nigeria. Can groundnut is an introduced crop. I'll call all the introduced crops to you today, and you will see that our forefathers were wiser than us. Groundnut is introduced. There's no bush you will go to in Nigeria and you see groundnut growing, and you will bring to a house of plants. Groundnut, cocoa, no, plantain and banana, pawpaw, guava, mangoes. All these crops are introduced into Nigeria. God did not put any of these crops into Nigeria. So the questions for this crop were asked by our fathers. 2 questions on the woman. That's the first question you ask also. Yeah. Then the other side we say, also.
Okay, I think at this junction, we would like to call on the National Biosafety Management Agency, representative of DG, Mrs. Vendo Scholastica, for your presentation. You know, the concern about GMO is such that it's enormous. But the truth of it is, any new technology, definitely you ought to have resistance from people. But at the same time, you have to understand that there are some things you just need as a matter of necessity. Our population is growing. We need to feed this population. Thank you very much.
Thank you very much. Members of the high table, farmers, I didn't know you were here. Good afternoon. Students and all stakeholders, good afternoon. Oh, I can't hear your voices. But I hope we enjoyed our.
Your concerns are very germane. In 2014, as a middle cadre officer in the Federal Ministry of Agriculture, there was a file sent to me, and the file had to do with biosafety, biotechnology, GMOs, etc. At that time, I knew next to nothing about these three things. I kept the file under my table. I went around trying to get information. I couldn't get because apparently I was using the wrong persons. 4 days later, very short man on Dashiki, on our corridor, came blabbing seriously. These GMO people, no, we shall not allow it. Of course, it was an answer to my file. I drew him close. Parker, please come. Let me understand what you are talking about. No. See, it cannot be approved. Oh my God. The next thing I wanted to douse the tension. Said, where are you from? I'm a Nigerian.
Yes.
How many of us can relate to this story at your first instance of hearing about GMO? I'm sure so many of us. We can relate to it. This is what it was for me. And exactly 10 years' time, I'm here talking about the safety of GMOs. Please, can you clap for me? As you've been told, I'm representing my DG CEO, Madam Agnes, or Dr. Agnes Asabara, the DG CEO of the National Biosafety Management Agency. We've all been talking about perception.
Correct.
This is a bottle of water. Some people will see it as half full, others will see it as half empty, some still will see it as full, while the mathematicians will see formula. The engineers will think that, well, it's too big. That is why it's the way it is. The philosophers, is there really a glass? Is there really a bottle? Of course not. They will philosophize. Then the skeptic talk about the formula of the mathematician to calculate the value is entirely incorrect. Where do you fall into? The one that sees it as full or half full? The one that sees it as half full is an optimist. The one that sees it as half empty is what? Pessimist. The one that sees it as full is who? The chemist. And the one that is talking about formula is who? Mathematician. So we are all free. This is how God made us to see things from different angles. Hence, your concerns are very, very germane. It is because of that I'm presenting this paper, to set all the records straight and for you to have confidence in MBMN's role as a competent authority on biosafety. What is the rationale? The federal government of Nigeria recognized, like I said when I was talking earlier, the potentials of modern biotechnology, and hence put a lot of things on ground. I think you can all hear me. Put this institution on ground, put the national biosafety on ground to ensure that we get the maximum benefits. This has led to enormous achievements in that sector, such as the approvals mentioned by our guy at the top. However, the very populace that is meant to benefit from these technologies that are meant to be protected against the potential adverse effects are being misled, sometimes to even taking us to court. Hence the need for this engagement. What is even modern about technology? We have heard so much about it, but so that the least among us will understand. It is manipulation of genetic materials beyond what would normally happen naturally. For instance, your bitter leaf, you want it to be sweet leaf. You just take the sweetness, the sweet gene in, let's say, sugarcane, and then
you infuse it into the bitter leaf. It now becomes what? Sweet leaf. That is genetic engineering. Is either it is giving you a little product or it's serving a particular product. And the outcome is what we call GMOs. They've told you a lot of advantages in GMOs in modern biotechnology. So I'll just mention a few. All strata of the nation have one thing or the other to benefit from these GMOs. Farmers, as it were. We look down on farmers in society, isn't it? An average farmer is looked down on in Nigeria. But even if you go to developed countries, for those doing GM crops, they are hero-worshipped because they have the wherewithal. Our farmers really want to be recognized someday for what you do and appreciated. Do you want to? Yes. Precisely. Then for consumers, good health, nutrition. For our researchers, fulfillment in what you do. That etc. is being talked about. We talked about concerns here and there. Majorly, these concerns can be divided into three aspects: environmental, food and food safety, social economy. Environmental, food and food safety, social economy. And these are the three major things that the biosafety addresses. What is biosafety here for? It is because of all their goals that I mentioned that biosafety became a means of addressing potential adverse effects. Please underline the word potential. That is may. Is not absolute potential adverse effects. And this is because nothing on earth, nothing, absolutely nothing, is absolutely risk-free, isn't it? If I ask all of you here now, what is man's greatest desire? You will say love. You want to be loved. You want to be appreciated. But do you know how many times love has sent you to? You understand what I mean, don't you? Therefore, biosafety is the application of laws, policies, regulations to prevent, minimize, or eliminate potential risks that modern biotechnology and GMO may pose to the conservation and sustainable use of biodiversity, taking into account risks to human health. Like I said, the issue of concerns in the application of modern biotechnology is not restricted to Nigeria. It's global. And it was so first discussed in Rio de Janeiro in 1992. Thus, the Cartagena Protocol on Biosafety was born. And the Cartagena Protocol on Biosafety was adopted 2000 and came into force 2003. Its aim is to ensure the safe handling, transport, and use of LMOs resulting from modern biotechnology. Now, that Cartagena Protocol has become an international binding legal instrument and a recognized international regime on regulation of biosafety, so that what we are saying is not restricted to Nigeria. Is an international thing. What is the objective of this Cartagena Protocol? It is to contribute to ensuring an adequate, I always stress that language, adequate level of protection in the field of safe transfer, handling, and use of LMOs, that is genetically modified organisms, resulting from modern biotechnology that may have adverse effects on the sustainable use of biological diversity, taking into account risks to human health and focusing on transboundary movements. Now, this is at international level. What our Big Daddy said, the journey to biosafety started in Nigeria, 1992, when Nigeria signed the Convention on Biological Diversity, which is the mother convention on issues of biological issues. 1994, the first biosafety guideline was drafted then by the Federal Ministry of Public. There are so many chronology, but let me go direct to when Nigeria signed the Cartagena Protocol in 2000, ratified it in 2003, and started the process of the law on biosafety in 2008. Mark you, 2008, and eventually was passed in 2015. Ladies and gentlemen, how many years is that? From 2008 to 2015. 2017? 2015, sorry. 2008 to 2015. How many years? 17 years. Is it 7? 2008 to 2015, okay, 7 years. So it took that long for your legislators to study in depth what of this thing was talking about. I first of all heard about it in 2082. And then somebody will now come and say that law is weak. That all big legislators and the scientists and everything working on it is weak. What are you talking about, Nigerians? In 2015, this law was amended to include emerging technology, just like the one our sister gave us a lecture on. Thus, the mandate of the agency, in simple terms, is to ensure that we put in place regulatory framework, institutional and administrative mechanism for safety measures in the application of modern biotechnology and the products thereof, with the view to preventing any adverse effects on human, animals, plants, and the environment. Specifically, Section 22 of the Act says, no person, institution, or body shall import, export, transit, or deal on GMOs without prior approval of NBME. If you do not learn anything today, if you can't remember anything today, please remember this. And please, we are going to say it after me, because ignorance of the law is not what? An excuse. No person, institution, or body shall import, export, transit, or deal on GMOs without the prior approval of NBMA. Thank you very much for being there. What are the events to regulate? Like I said, from containment down to transvaginal movement. Containment, that is in your lab, confined field trial, multi-locational trials. At every stage, you must come back to NBMA. I've done this stage. Please, I want to continue this other stage. All the stages are being regulated by NBMA. From the lab, greenhouse, confined field trials, like I said. Now, we are back to our case study. Poor resistant cowpea. What is the importance of this cowpea, black-eyed peas? How many of us can speak Yoruba here? None of us. None. If you can speak, please sing with me. Aya mi ò já, ọmọ ẹ, aya mi ò já láti bíbèjì. Epo fẹ́ wá fẹ́ o. The transition is this: I am not afraid to give birth to a lot of kids because there is oil and there is cowpea. That is to say, the importance of cowpea or beans. Beans is highly nutritious.
It ensures food security. It is drought resistant. You can plant it in a whole lot of plots of land. It improves the soil. They'll tell you after planting cassava, maize, and the soil is no longer fertile, you plant what? Beans. It's income generating. If you have beans and oil, your child will be healthy. That is the summary of the importance of beans. However, there are certain factors that limit its growth. We talk of pests, diseases, drought and heat, and weeds, etc. However, just pests and disease constitute about 80% of the wahala. And of these 80%, only one pest called maruca constitute between 70 to 75% of the wahala. That is, if you have a bag of beans, or if you are supposed to have a bag of beans, 75% of it, you don't have it to yourself because of what? Maruca. Hence, maruca is an economic pest. How is it produced? How is the PB cowpea produced? Our brother there has already given us how beans generally are produced. For once of time, let me just do that. Now, how do we regulate the cowpea that is now in the market? The first thing is you, as a developer, which is AIT, AATF, and IAR, submitted the application in the prescribed form, download it from the internet, along with a dossier and a covering letter. A dossier contains everything about what you want to do, who is involved. You will get to know what the dossier contains as you go along. This is acknowledged within 90 days. The agency does a checklist of everything you sent. If there is anything that is not there, you are asked to bring it back. Then there is public display of your application. Somebody talked about communication, carrying people along, openness, transparency. There is public display in 3 national dailies, including our own website, for everybody to make their own comments for 21 days. We collect all this. Then we form what we call National Biosafety Committee to meet and review the application. And also the National Biosafety Technical Committee. These all review the application and give their advice. It did not depend on MDMB to accept their advice or not. The final decision is taken within 227 days to either reject or to accept. If it is rejected, you are informed. If it is accepted, it is posted on what we call the Biosafety Clearing House. You have a review taking place there. These 2 committees meet together at the same time in different groups, and they are composed of experts that are relevant to what we are doing. Biosafety regulatory approaches. It stands on 3 legs. The 3 legs are risk assessment, risk management, and risk communication, which she has talked so much about. The risk assessment examines all your concerns, all these things that everybody is talking about, and this is done by real experts, like I said, that are relevant to the organism in question. Then the risk management, it establishes and strengthens regulatory framework to mitigate potential risks. Now, what are the contents of the risk assessment? First, the biodata of the applicant, the name, the contact address, postal address, qualification. Like when I listen to your BCS, your BCS were so beautifully spoken. But if you write his name inside our application as one of your maybe resource person or whatever,
or it may not be considered. It must be somebody that knows about that field. Then description of the PDR, characteristics of the donor, where you are taking the listing from the gene that you are interested in. What is the safe history? What's everything about it? Then characteristics of the recipient organ, the place you are putting it, the vitamin that you are putting it. Tell us about everything about it. Then information on the release, characteristics and factors affecting the survival. When you're working on the field and everything, what was it like? Then number 6, PDRS interactions with the environment, the appetite, the environment behaviors and etc. Then safety consideration, history of safe use. The sugarcane you want to bring the gene from, what is the history of the safe use? Is it allergy? Is it poisonous? These things you have to let us know. Potential toxicity, potential allergenicity, DNA gene transfer, substantial equivalent. By the time you are done, except for the gene of interest, the gene that you are interested in, every other thing should as much as possible be the same. However, if something is expressed and is positive, for instance, maybe you give now increase and that was not part of what you were doing, it's a good thing, that is accepted. But when it is negative, it is thrown out. Environmental consideration, which somebody has talked about so much, weediness, invasiveness. Socioeconomic consideration, like cultural practices, some people don't eat pork. So if you are taking your gene from pork and then putting it into chicken for me, that would not be fair on your part. Rural employment and all that. Regulatory decision for PBS. For confined field trial, we got the application in 2009. Application of confined field trial for 12 events carrying a CRY1 ABG by AATF and AIR. Then in 2018, permit was granted for another CFT, this time CRY2 ABG, to serve as backup to the CRY1 ABG that was previously approved. Remember, it was 12 they brought in before. Then from 15th August 2018, public display of the application dossier, like I told you, for the CRY2 AB. Then permit was granted on the 26th of September. Then for PBRO commercialization, 18 December 2018, public presentation of the PBRO, like you have just said here, it was a public discussion. You ask your questions, and all these questions were put into companies. In 2019, only one, which is one that has been approved now, of the 12 that they've been working on, was approved for commercial release. That's the picture of the permit. I don't know if it's on the board. You have the picture of the permit. You have the picture of the permit. That is what it looks like. Then content of an approved dossier or approved document, objective of the release, so that if you tell us you are going to use it for maybe processing, like for something else, it's not allowed. Identity of the PBR, period of validity of the permit, condition of the permit, and then monetary requirements, then your own obligation as the permit holder. And one of the obligations is that you should teach farmers exactly what they should do. Thereafter, we'll carry out monitoring. The monitoring is to ensure additional risks to health and the environment associated with authorized tilling is noticed or recognized if anything crops up. Unintended effects of commercialized PBS cotton, we are not human, like I said, we are not 100% substantial, safety. So if anything will happen, then any contravention of permit condition, and then prediction of the risks, all these things are, taken after. Then after that, we have enforcement. If you don't do what we ask you to do, fine prison for you. Or if anything comes up and you not let us know. Therefore, stakeholders, The PBR copy approved for commercial use by NBMA has gone through the internationally accepted assessment and approval process and is therefore considered safe for human and animal consumption within the limits of scientific evidence. Endpoints therefore. NBMA safety assessment process for PBR is considered that it is safe as that of its conventional counterparts. That is, there is absence of harm. That is the one leg assessment, risk assessment. The second leg, I talked about instruments and all that. I don't want to bore you with all the instruments we have. I'll just summarize it. We have a lot of biosafety regulatory instruments, so many, and they are considered one of the best in Africa. In fact, other countries come visiting us and asking us how we do it. Even at international level outside Africa, our instruments are respected and used as sample. We have critical mass of well-trained staff and stakeholders. On daily basis in my office, training continues on daily basis by and for the staff. We have foreign trainings, and then we also have trainings like this. Institutional biosafety committee. For every institution that we license or permit to carry out modern biotechnology application, there is an institutional biosafety committee constituted to oversee what we are doing. Engagement of experts like I've told you in our risk assessments. We had a GMO lab and analysis lab that is one of its kind in West Africa. I talked about nationwide inspection, survey, tracking, collaboration with stakeholders. You heard everybody saying they collaborate with us. Public engagement, participation, and engagement to ensure transparency, not only transparency, but for you to have informed choice. Effective communication channels. Then what else are we doing to improve what we already have? Let me not bore you with that. NBMA is not established to stop GMO in any way, but to ensure its safety. We need the cooperation to get the best out of it. Because the war of GMO, as it were, is both political as well as trade war, if you understand what I mean. Your simple economics, if you have Milo and Bombita, and you are buying more of Milo, will you still buy Bombita? Will you still buy Bombita? If you are buying Milo, will you still buy Bombita? No. So that is the trade war. Concluding message. NDMA is well their position are committed to, among others, ensure safety in the use of modern biotechnology by providing a holistic approach in the regulation of GMOs. It provides an enabling environment for indigenous and foreign scientists to practice modern biotechnology safety so that they are not jackpotting. Opening avenue for research institutes and the entire biotech industry to break new grants that will solve some of our problems. GFO. Trust the government establishment that is there to ensure safety for GMOs. The NBMA have what it takes and is working towards what it takes. What do you have to offer everybody here? Come on board. Let's ensure safety of application of modern biotechnology and GMOs and get the best out of it. Good day, everybody.
Thank you very much for that eloquent presentation from the representative of the National Biosafety Management Agency. As you are aware, they are the ones saddled with the responsibility to ensure safe practice of modern biotechnology and its applications. Thank you very much. A round of applause for her once again. At this time, I would like to call on Dr. Matthew Doe, the Country Coordinator, Programs for Biosafety System, PBS, for his presentation, sir. No problem, sir.
Madam Pico. I prefer to sit down here because I don't want to sit. I can't stand. I'm not feeling, I think I'm developing my hair, and I don't want to sit down there and talk to people. So I'd rather sit down with the rest. More people they need to see me or hear me. Just take a look at that. Can you read everything on it? Huh? Yeah, I'm talking about reading. Did you read it? Somebody has talked about label. That thing is labeled also. Yes. But could you read it? No. So we're going to talk about label. Good afternoon, everybody. I'm sorry I have to do this. I don't want to sit down there and talk. I'm developing some feedback, so I'll be taking. So that's second slide. Is the first slide is my name and the organization I work for. Is that the second slide? Yes. Okay, this is my office. What we do, where we are. We're in 7 African countries plus 1 in Asia. We provide technical expertise. I paid for this workshop, for instance, which services enjoy. And we provide training to government institutions and non-governmental bodies that are also interested. The outline of my presentation, I already talked about one. Then I'm going to introduce safety. What my introduction to this? All GMOs have safety evaluation, and they predate the time GMOs came into the market. GMOs came into the market since 1994. But here we are, 2024. We are still talking about GMOs are safe. By 2018, the area that was planted was 491.7 million hectares worldwide. Since GMOs came into the market internationally, no genetically modified organism has been demonstrated to be a hazard or cause harm to human consumers since 1995. Nobody has pointed to one. But this GMO is GMO can. That is what we are always saying. I like to think as a Nigerian that our attitude mirrors our politics. Nigerians have not been satisfied with the government they have for a long time. So anything that is coming out from the mouth of government is the same political attitude we have as politics.
Yeah. He talked about insulin. Insulin is the last word on this slide. Diabetes. Before people found a way to make insulin, Abraham, there are two beautiful ladies here. Can you wait there? We have insulin. I was talking about insulin. So before GM insulin, people were getting insulin from the pancreas of pigs. Am I right? Yes. So they kill pigs and get insulin, I think, from the pancreas. Meanwhile, the people who have diabetes are suffering until somebody found that you can get bacteria to produce insulin, and that brought the cost down. Now, if you are thinking that you are not eating GM, there's nothing strange. Your attitude is just like that of Europeans. So, Europeans don't plant GM. They don't plant GM. Except Spain, largely, parts of Portugal, and maybe the Czech Republic. So I went to Spain, to a GM cornfield, and I asked, you are in Europe, why are you planting GM corn? Oh, we don't eat it. So what are you planting it for? We feed it to our sheep. You throw the sheep into the sea? No, we eat the sheep. So when you hear anti-GM people, Nigerians talking, they tell you Europe does not consume GM. But in my place, worry, what we say is waiting rat shop, therefore possible. If you are a cat and you eat rat, if the rat ate poison, you know that you are eating poison also. So in Europe, they import a lot of GM food from South and North America. Canada, USA, Mexico, Brazil, Argentina. There's a big map showing the amount of soybeans, corn mainly, that are imported into Europe. Because of their livestock, they do not produce enough grains to feed their livestock. And their livestock, so if you are hiding from GMO, if you eat chicken, egg in Europe, that chicken adds GMO called soya beans or soya milk or corn. So there are environmental issues. And what are these environmental issues? Weediness. Does the crop have the ability to become a weed? If we plant corn here and the corn becomes a weed, everybody will be happy. You just see corn growing carelessly by the roadside, you will help yourself for your corn. So we test for weediness, we manage both environments and unmanaged environments. Then is the gene in the crop able to flow to another crop? Is that gene flow? Does it matter if there's gene flow? Potential for the plant to become a pest. Potential impact on non-target organisms. Non-target organisms. If you plant something, will it have harm on the insect, for instance, that are trying to control, and impact on biodiversity? So currently, in 43 countries, there's regulatory mechanism for the approval process for granting import or planting of GM. The lady who spoke last talked about the process. So we are one of 43 countries that have this process in place. Modified crops up to date. The second bullet
I've put the list. Well, I've put the list of plants that are modified genetically. Most of them are not here. Then the third bullet says commercially grown GM crops include potato. GM potato is coming. The GM potato, Umudike is the capital, is the headquarters of the Research Institute for Irish potato, like yam, like cocoyam. It's been tested and it has ability to produce 3 times the quantity that is being produced currently. So, GM on one side. On the left-hand side, you have conventional crops. Also, so what is the difference? I've attempted here to show some of the differences. When you go to the market, you might find different types of carrots, different types of cabbage. So, on the left-hand side, if you did not use genetic modification, you're going to produce GM. There's no taste. TEST. There's no testing of conventionally produced crops. But we all know that some crops, including simple that they are not. I have a grandson who doesn't eat granite. Because the very first time the child tasted granite, he had very strong allergic reaction. And I'm sure people here can find some other crops, including common cassava, like cassava leaf, for instance. People have said in the newspapers, people die after a meal of cassava. So it's not only GM crops that they are crops, conventional crops, that are very bad. So here, regulation of GM crops worldwide. Agricultural biotechnology is one of the most regulated industries in the world. Nobody is going to allow you to just bring a GM. It takes long time. That is why you will hear people talking about yes, where is it? If you have to prove all the toxicology and the geneticity and so on, that what you are producing is safe for human consumption. So, how do you prove that food is safe? Here, we must give credit to any man. Today, we know what to eat. And also, it wasn't always so. People learned that you have to boil yam or roast it before you eat. If you don't boil yam, you have yam, if you don't boil the yam before you eat it, it will be poisonous. The ordinary yam which you boil, the process of boiling makes it palatable, makes it not poisonous. If you eat yam ordinarily, you get it. And one of the most popular vegetables throughout Nigeria, the root is poisonous, it kills. Few people know this, so we don't publish it. Ordinary plant that is sold in the markets, part of it are poisonous. Part of it is what we eat. So the food safety evaluations necessary for GM crops focus on realistic, not hearsay, realistic and rare, and are outlined clearly in the Codex Alimentarius guideline. There's something called Codex Alimentarius. It is a United Nations organ, and Nigeria is a member. So those people who are talking GM might not be safe, they pretend not to know that before any GM food comes to the market, it will have passed through the Codex Alimentarius, and then there are two people you ask.
There's World Health Organization. Everybody knows World Health Organization. And then there's Food and Agricultural Organization, both of the United Nations. These two bodies, they will not allow anybody to bring into the international market space food that is poisonous. And they all have representatives from different countries. So the food is certified by FAO and by the World Health Organization before the foods. But the anti-GM people, they're all over the world, not only in Nigeria. They still go ahead, they undermine the presence of those characters, those certified people, and say talk, don't continue. So on the left-hand side here, you see 5 steps that testing must take. And ends on your table. So it takes time. Between 10 to 20 years, depending on the research requirements. So, talking regulation on the right hand side, you will see the regulatory mechanisms that are required. So, there is something called equivalence. What was he talking about this? You've heard of the epidemic? It's not an epidemic, it's not pandemic. There is today epidemic wars going on in the world. Everybody is a newscaster,
Everybody has a television station. You take your phone, you ask your friend, you say something, then you pass it to Mr. B, and you say, let it go viral, let it go viral, let it go viral. Is that not what we're doing? Yes, let it go viral. This is the infodemic. The moment you hear it, you read it, what time of the day, then you pass it to a friend, to a brother, to a sister. Even pastors have become homes. Pastors who stay in Europe or Nigeria, they will tell you don't use 5G technology. The man knows next to nothing about how telephone works. Now it is malaria. So there's an epidemic going on in the world. Everybody is driving a phone, carrying stories around the whole place. But I'm just going to show you the last slide. There are two ladies here. Are there two Sarahs here? Okay, let us show them. Can you see them? Sarah. Sarah, start now. Do you see them on the board? No. The one, okay, the one on the. These two ladies are Sarah. The two ladies work in the same place. They have been eating GM. I myself have eaten. This photograph here shows them publicly eating moi also, moi and akara, to show that what they preach, eating is believing. Am I right?
Yes, sir.
They have done it, but they didn't do it here today. So they have been going around Nigeria showing that the beans Madam was talking about is edible, it's not poisonous, they have got grown horns, and it is safe. This is their photograph, it's all their place. The man with white hair there, what is his name?
Jean-Baptiste.
Yes, the man is from Senegal, Burkina Faso, but he is the country representative for the African Agricultural Technology Foundation. That's where I want to stop my talk. If you have any questions, I'll take them before I go back to my seat.
Are we asking questions?
Yes, sir. Doctor.
Sir, okay, sir. Sir, you see, when you asked before, the concerns and why people are very skeptical on GMO.
Thank you, sir, for really making this very simple and understanding. I'm taking away two things here today, that actually there are concerns on GMO worldwide, not only in Nigeria. So it's not a Nigerian thing. So I will no more condemn Nigerians for condemning agricultural products. Secondly, that because of that concern, the federal government has set a regulatory board to make sure that before anything comes into the table of a consumer, it has passed through a lot of scrutiny. Well, my own concern is this: the magical way these products developed is also a source of concern. Imagine a chicken that takes 12 to 16 weeks to get mature, and somebody is raising a chicken for 3 weeks, 4 weeks, bigger, more nutritious, and so on. So it is suspicious. How can, naturally, when a child is born, it crawls before standing, before walking. It's a natural justice. Yes. But this one, you plant it today,
The oil palm that stays 3 years by NIFO to start fruiting, they will tell you more than 6 years. They will tell you in a year plus that this one came from Costa Rica or whatever, that it is GMO, and that in the next 1 year you will start harvesting. You start imagining what is happening. Okay, why is it this one that takes naturally 3 years will stay 1 year? Eh? Like when you see a chicken that is GMO, let me answer you. Okay, thank you very much.
There's no chicken for 3 weeks. That's one. There's no GM chicken. Okay, there's no GM chicken.
How do we know the GMO?
Where's I was passing 2 things around. Did you see them? Huh? Were you able to read everything? Were you able to read everything? We'll come back to that, please. Let me just answer you. There's a list. There are many systems of crop improvements. It is not GMO or nothing less. You can get increased growth by other means, and I listed some in my paper. When you get there, you see some breeding techniques. There are other breeding techniques that will make you get big fruits. You see big mangoes. It is not GMO. It doesn't necessarily size. Please, because we are hungry, we're always looking for. Yes, that is not the only thing. There's pest resistance. There's drought tolerance. Even flood tolerance. So there are many characteristics. Even saltiness. I come from the Niger Delta. We can't plant because there's a lot of soil that can't grow. So you can. There are genes that pump out salt from organisms. That's what the woman was talking about. Let people find the genes in different plants that do different things. So size alone is not. There's a human growth hormone. You have seen cretins. You know those short people. Just so there's a simple thing they lack here. That is why they are short. It's not because the devil doesn't like their mother. No. They lack a hormone, so they don't. The bones don't get elongated. You can create that hormone and you can put it into fish. But people that has ethical questions. So it is not only size. That's one. If you go to Osomai, see in NIFO, they actually look for fast-growing palm oil seedlings. Mutation, variation happens naturally. So they take these things they have found. If they go through us, I get to Africa because I know that it's a very good source of yield production for. So they go there and collect it and then do crossbreeding and then you see what is happening. You can get improved. Yes, it's not GMO. It's not GMO. Does that so? I'm a farmer myself. We don't have GM chicken here. It is breeding. If you have 1,000 layers, if you raise them to 6 months, one layer after about 5-6 months will lay egg. Out of 1,000, there will be number 1 to lay egg. Once that first one lays its egg, you know this one is different. Out of 1,000, it is tough. So if you want to breed, you're going to take that one first. Then maybe a day or two later, maybe a week, you see number 2. And then after some time, you begin to see eggs. But those that are fast, they have distinguished themselves. That is how we do selection. That is a simple process of selection. The feeding. Who used to feed chicken the way we feed chicken? If you take
There is something I want to clear, especially the concern raised that you have addressed. By the grace of God, I did agriculture in my first degree and still doing agric even in my third degree. When we were in agric, they taught us budding of different crops. And in Benue today, you will see different varieties of mango, like GMO. A typical tip man bought that mango. He has no idea of whether it's modifying genetic support. Even we were taught how to do it. So it's not everything you see that is big that is GMO. And again, there is one notion that we are having. And thank God, I always tell people that farmers' education is very important. Let us make this GMO farmers own. They should be fully aware. They should have full knowledge of it to be the one advocating to the fellow farmers about it. If not, this grammar will continue. Anywhere you go, Chief was saying it that 20 years ago, this same story, because farmers have not claimed ownership. If they claim ownership as a farmer, I can stand firm to tell farmers that GMO is not harmful. If I can say it in our meeting and everywhere, farmers will know actually it's just a baby. So that is one concern and one nice contribution as farmers advocate. And again, the GMO they're talking about, there is no scientific proof that it is harmful. But if you are not informed, you will be deformed. If you are not aware that it's not harmful, you will never believe that it's not harmful because the amount of community harmful things are more. But until the campaign continues and farmers claim ownership. So that is one part of it. And then lastly, I want to say that the Southeast, this is just a move down. This is the first time I can say this campaign started as a sensitization to farmers. Let's make it, as Mami Gidado rightly said on her presentation, then they will go to other states so that it will be domesticated to the minimum that farmers can go on their own, even without offer, to do their sensitization and campaign on behalf of offer. Because when they have full knowledge of it, that all these mites, that this negative message about it is not actually true. If they are not convinced, this story will remain the same. And again, the availability of the crop is very important. Like the farmers that came, that we invited, all of them are asking me, okay, after this 1 lesson, Southwest faced that concern when they were presenting their resolution or something like that. That the only question they could not answer is where is the seat? And I believe the same question arose here too. Where are the seats? So that after this, they can practicalize it and show that actually what they are saying is the truth. Thank you.
Okay, let me make a remark. Professor Sylvia Uzochukwu was the person, friend to Obi. She was the person in Southwest. What I always encourage the local coordinator to do, involve the state government. One. Two, your entry to the state government should be the ADB. These are federal people. If you wait for 37, it's not going to come. The ADB instituted by the World Bank long time ago. That is the purveyor of technology. In Enugu, I know that it used to be near Berkeley or opposite the Polytechnic. In those days, on the right-hand side, people are going towards the market. I don't know whether they're still there or they have a new office. It's still there. Okay, because I used to do some farming myself here. So the states, if the states want GMO seeds, they know what to do. It's not enough to get fertilizer. They need to get seeds. Let the ADPs in the states ask federal agri or Rhodes office. That's number one. 2 weeks ago, I was in Kano. We went to an Alaji's farm. The Alaji has 2.1 and 0.8 hectares of cowpea. In the 60s, a man, an engineer, Alaji Bako, Audu Bako, I think. If you have driven to Kano in the last 40 years or 50 years, you will notice that on the right-hand side, just before you enter Kano, it's heavily irrigated. Who has been to Kano in the last 50 years? You will see tomato, corn, any time of the year. So the question we Southerners should ask ourselves first, do our governments take agriculture seriously? So this man irrigated huge land more than 50 years ago. He built Bagauda Lake. Bagauda, the lake is formed by damming of the Jamare River coming from the Plateau Highlands, flowing north. That river goes eventually into Lake Chad. To stop all the water from going. So, after damming the place, he now reticulated. So they have water. Any time of the year, they have water going through villages. This man is planting seeds which he will sell. I just mentioned the number. I have his phone number here. I have his number. 2.8 and 2.1 and 0.8. Big land. The person supervising the land did use service with him and from Kebbi came to come. The person is there. Where's the infrastructure for agriculture here? When I say here, I mean the south. I come from Delta State. So the government have to be politically aware and wants to do the same thing. Do the governors, how much do they spend on agriculture? Are they ready to send people to get these seeds from NAFTA and so on? Where are the big farmers? Is the private sector involved in agriculture in the South? This cowpea, when it came out, somebody in the background was asked. The person said he was not interested. He sells it. So it is not a government thing. It is business. If you are waiting for government all over the country, no. Secondly, there's what you call farmer preference. The cowpea, that the story the lady didn't go into the details is the maggot that is eating the beans is here in the rainforest. They migrate up north, do their damage, and die there. Maruka is the name of the north. Now, we don't like white beans. Most Southerners prefer brown beans. Am I right? Yes. So, because this technology was done as earlier, they used the farmer preferred variety, white beans. That was what they put the BT gene into. They now have to put that same gene into the type of cowpea that different parts of the country like. But they have started with one. And the field I went to 2 weeks ago is white cowpea. They have tested with farmers in Adamawa and Kwara. The nearest to this place that I know of is Ife at the university. So the universities themselves have to find a way of liaising with people outside here to say, we want to try this thing ourselves. So the universities and ADP, they need to reach out to their counterparts. It was done in a university. So the university need to reach out to their counterparts outside the zone. Yes, sir.
Ogabet.
Thank you very much. Once again, I want to appreciate the organizers of this workshop. It's worthwhile. And the hosts and the doc, like me, was a very wonderful insight. As farmers, let me also introduce myself. My name is Chisomiti Nonola. I'm the state youth president of Anambra State All Farmers Association of Nigeria, Anambra State chapter. You see, what I observed in this kind of environment, which is very, very conducive, an academic environment, I have to appreciate and praise the organizers for bringing this to the Southeast. It's a reawakening event, reawakening project to reconscientize our thinking, where we are going, whether we are looking into the future. Because I said belong to the future. People like Doc and some of you have already gone beyond, the peak. You are at the climb to some extent. I've been worried since I've been sitting down listening. One, my observation: these projects you are organizing here, for me, for it not to bring in a lot of initial return, is so enlightening and so compact that only a day is not enough for such workshop. That's number one. Two, the need to bring in more farmers is very, very there. I was very, very impressed when we are countering the requests. At least 10 farmers from each state are here with me to represent critical local governments that are very agrarian local governments. You see, there is something we call information, there's something we call communication. Nigeria lives in information. WhatsApp,
do this, I tell you this, you hear it. But there is an element of this one that tells on communication. Communication means let's understand ourselves. Let's practicalize it. Let's do the needful. So I think for that to happen, we may have the need to organize more of these events. I don't know the capacity of the sponsors, but I believe since it's a government thing, or since it's not a government thing, the stakeholders that are involved will have to rethink to get maximum output and impact. Then, there is something that's lacking. Farmers seems to be one end. The academic seems to be the other end. The government on the other end. It can't work that way. The need for synergy, a platform of synergy, not just a platform, a technical platform for synergy is required. Our parents do their own primitive way of agriculture. We have to add value and bring in innovation. And that's the direction we are going. If that direction will be actualized, there is need for a technical platform between the farmers, the academic, the scientists, the biotechnologists, and the government. It is not always bring the farmers to here. We have to really understand, because we are the people that will go to the field and market what you are doing. Just many of us have said it. In every business that is for market, those that will carry out the marketing, we are the farmers. If we don't understand it, the market could be good, the product could be good, but the market might be bad to sell. That's why some farmers are still doubting. For me, I'm not doubting. I know what it means to have a chicken, a broiler that will be very, very fat in 6 weeks or 7 weeks. So that synergy is what I'm proposing, that we'll have to look into it. Then, another thing is that we have to complement each other's efforts. Let it not be academic all the time. Farmers are doing their bits. Chief Dan Okafor have been working hard, doing a lot in this part of this direction. I think if there is support, because the platform to reach the farmers are there. You can't tell us to go to ADP to go and tell government what to do. But I believe when we have synergy, the advocacy will be stronger. If they come out from political point, there will be somebody within that technical committee to marshal it out. Because government needed good advice. If the advocating team are strong enough, government will rethink. Because it is them that will take the glory. So for me, I feel at this point in time, this project has to be domesticated, just like the way she said, to complement what we are also doing and what we are doing at the same time, especially the AFAM platform in Nigeria. Thank you.
Let me just say this. Sit down. Yeah. Information also. Information. So you create a platform. Create a platform. Let's leave here. You create a platform that you can control. See your sister here, Sarah. She's near the top of one particular agency in Abuja. If you can link, if you are the link for that person, if you have an Anambra, you're from Anambra also. As I sit here, between Onisha going to Enugu, for serious agree, I can only think of the left-hand side. And now, you know what I'm talking about? Between there and the Gogogo. You know Gogogo? And the Suka. I know the terrain very well. So, that part of the two Enugu and Anambra State hold a lot of promise. If you can organize your people and you have a platform, you are sharing information, you have
critical question, critical assistance to ask. It is possible that you can look at your sister there. Send her a WhatsApp message. She says to you, you share it. Develop something. There are 774 local government areas in Nigeria. It is going to be difficult for anybody, certainly not me. Madam, we have to put this time in to figure when I will be around to do this workshop. So as we go around, different people. Professor Obi is from Cross River, elections in Ebonyi. So we need local chapters. If you think of something, because information is key. Today, information is critical. If we have something that is Anambra specific, and you have a request, you tell your commissioner that we have been talking with NAFDA. They say we should go to ADP. This new technology is coming. If you think this technology is, somebody was talking magic, okay? You are talking magic. Yes. Let me just tell you some of the new technologies coming. The feather of chicken, you can get chicken out of the feather. So people who want to choose to eat or not to eat, the feather, where is the chicken coming from? It's not from the egg. So what is the difference between the feather and the chicken itself? So from the feather of chicken, the technology already exists. 1. 2, the technology is already there. They are growing meat in petri dish. 700 years ago, 700 years ago, the white man came to Africa. Also, we are here looking at the sky. They are going to the moon, they are going to Mars, they are Mercury. Not so, we are still here. You think they will carry yam to Mercury? They will grow yam inside the aircraft. We are still choosing which technology to adopt. So please, before you go, madam, have 5 minutes talk, exchange WhatsApp numbers, then start to create something. This can happen about the 5 Southeastern states. Are you following me? But funding, this is not the government funded thing. This is money from outside Nigeria that some of us brought. So then you have to say, if you tell me, for instance, Mr. Dow, want to hold a meeting near the airport in Anambra. I said, okay, who are your stakeholders, who are your participants? How much do you have? How much do you want me to put on top of what you have? If you say, well, chish, I say, you can ask that. So organize yourself and let us see what you're bringing to the table. Then you can bring people and you can organize. You have organized. This is not the first time. We were here about 2-3 years ago. I met the vice chancellor one again. Yesterday she said, I'm not going to see vice chancellor. So this is the second time we are doing it. We could have gone to Umudike. So you want to talk to your brother? I know. Start there. After the workshop.
So I think what he's saying is, what does it take to attract you and this team to a space like I'm in a university? I am thinking that you should come and talk to the staff about it. What does it take to do that? To bring you to my university to talk to.
Which is your university?
I'm in the University of Agriculture in
Imo State.
Imo State. Yes. So I want to University of Agriculture and Environmental Sciences. It's Umuagbo in Imo State.
Where is it?
Umuagbo in Imo State.
It's near where?
Sir, I'm only taking this one.
It's Port Harcourt Road.
Yes, Port Harcourt Road. Down south or north?
North.
That's the Okigwe Umunoshi local government. That's where?
Get to where? Umuagbo is on Port Harcourt Road. That's where the university is cited.
It's okay, talk with madam. And you can just exchange telephone number, and then you will.
Actually, now we're going to next
No, that one is I'm talking about in my university. When we need this kind of sensitization.
All right, if you have further questions, please can you just write your name and your number. It should be taken. And please, thank you for your active participation. We've already sent a survey to your email or WhatsApp. Please kindly help us and fill it. Your feedback is really very important to us. Please, as we continue to take a further presentation because of time.
Did you send the papers in our mail?
We will send it out. For now, we have your survey. Once you fill the survey, you get all the presentation sent to your mail. Thank you very much, sir. That was a wonderful presentation. Thank you, sir. Okay, so to take us further, we'll be taking the next presentation, which will be taken by Professor Ubi, the former president, Biotechnology Society of Nigeria, BSF. And the topic of discussion will be promoting biosafety measures to safeguard agricultural biotechnology for food security and One Health. Please, a big round of applause for Prof.
Thank you very much, MC, the Vice Chancellor, and the chairman of this occasion, ably represented by the DVC, the chairman of the local organizing committee, Dr. Christian Yak, and all the other stakeholders, all protocols are duly observed. Please, can you project my presentation? Okay, good. We're waiting for the presentation. So my presentation is on the promoting biosafety measures to safeguard agricultural biotechnology for food security and One Health. While it is coming up, I want to just summarize my presentation this way. Judging from the question raised by one of the prominent farmers, Chief, I don't remember your name, sir. Dr. Warren, yeah, you did say that if this technology is good, if these products are good, why don't you flood the whole place with the products so that we will have a...
Yes, why regulating it?
Yeah, why regulating it? Why don't we just have it so that we don't need to bother ourselves about this? Yes. So, from what the last, one of the presenters, who represented the Director General of the National Biosafety Management Agency said, that without biosafety, there will be no biotech. So, but here we are talking of modern biotechnology, which has to do with GMOs, the creation of GMOs and their release into the environment. Of course, when we mention biotech crops, people normally think that it's all biotech, but it's not all of biotech that involve the creation of GMOs. Things like tissue culture, things like marker assisted selection, other forms of biotechnology does is an international agreement which aims to ensure the safe handling, transport, and use of living modified organisms resulting from modern biotechnology that may have adverse effects on biological diversity, taking into consideration risks to human health. It was adopted in 2000, like she has said. So Nigeria has a robust biosafety regulatory framework that is anchored on the Cartagena Protocol. And Nigeria is not alone on biosafety, but follows international protocols, which ensures that countries involved have access to the information needed for making informed decisions about the use of whichever GMOs are released are considered to be safe. Precautionary measures are adopted in the whole process of the creation of genetically modified organisms, beginning from the laboratory and their release into the environment in order to guard against unintended consequences and perceived risks to agriculture, human health, and the environment, including non-target organisms, NGOs. So the whole process, please can you project that so that the audience can see? So it starts from the laboratory to the grow chamber or greenhouse, to CFTs, what is otherwise known as confined field trials, and then full safety assessment and general release. Much of this was elaborated by Mrs. Bello Scholastica during her presentation. But you must bear in mind that what is paramount in the mind of the competent authority is safety. They will not want to give you something that they already know is not safe. Therefore, every stage of the whole process there are three areas that people perceive that there could be risk. One of them is agriculture. The second one is environment. And the last one is animal and human health. In terms of agriculture, some of the perceived risks, the dean of natural science and environment was telling me that why don't we just take up the concerns of people and debunk all of them? So this is the concerns that they usually have. Many of them have been talked about by the previous speakers. Please can you roll down the slide to perceived risk of concern in relation to GMO. In regard to agriculture, the first one is the issue of superweeds. That is example. Would the GMOs lead to the emergence of superweeds that will be difficult to control by normal weed control measures? Will it lead to superweeds? Will it lead to increased use of chemicals in agriculture? And then will it bring about increased cost? The previous slide is agriculture. Will it lead to increased cost to agriculture? Example, will it increase the cost of agriculture arising, for instance, from the high level of chemicals, herbicides use? But the answer is no. GMOs are not making you to use more chemicals than you normally use. Even when you use herbicide-tolerant crops, it is the same dose of chemical that you are applying, except that in this case there is selectivity, in which case the crop is spared, while all the weeds are killed using the same dose of herbicide. You know the great roles that bees have in their pollination and then their food supply. Any day that there are no bees in the world, there will be no food and there will be no life. But this is not the cause. It's not because of GMOs that bees population are declining. Evidence points to the fact that sometimes, like when the bees are migrating, the bees, some of them may be old and then weak. And when they land on the inconvenient spots, they may not be able to relocate, rise up from there and relocate to newer grounds where they can have access to nectar. Now, in regard to animal and human health, things of allergenicity. Does the GMO food pose a threat to animal and human health by being allergic when consumed? You have been informed. Even non-GMO crops can be allergic. So it's not only GMO. There are some people who cannot eat wheat, couscous. They will have allergic reaction. Even some people may not be able to eat beans as porridge. They will have allergic reaction. It's not dependent on whether it is GMO or non-GMO. The people reaction differs. Is there possible effects of producing allergic reactions in some individuals when consumed as food? How different are GM food from conventional food in terms of allergenicity? And then look at the issue of toxicity. Does GMO bring about toxins than the non-GMOs? No evidence. You also have toxicants in other foods as well. People will come and tell you that GMOs cause cancer, but they have not shown you. They may bring a crop and put something like something on the head and tell you that this causes this, or it caused horns to develop from human beings like it. And people who are gullible, they will just believe it and think it is true. Remember that GMOs, especially those that are targeted towards insect or disease protection, they rather reduce the use of chemicals in the environment. They reduce the agrochemical burden in the environment, thereby helping to preserve the environment. It does not lead to more pollution than others because the crop is genetically protected. You don't need to spray. Like, look at beauty cowpea. Under normal circumstances, you may need to spray up to 7 times to protect your crop. But with GM, you may just need to protect your crop once. Spray the chemicals once. Just like also BT cotton. So it rather helps to preserve the environment and avoid much chemical pollution.
both the probability, that is the exposure and consequences harm of it occurring, and an assessment whether identified risks are acceptable or manageable. What that implies is that for there to be risk, there first has to be a hazard and also what? Exposure. If there is absence of hazard and there is absence of exposure, then there will be no risk. In terms of both have hazard and exposure must be present to have risk. Risk management. These are measures that are being taken to minimize or prevent risk identified in the risk assessment. Risk management constitutes all measures that are undertaken to manage, regulate, and control risk and prevent unintended management movement of NMOs as well as their adverse impact when they occur. All these things, aspects of risk management and risk assessment, they are being done by the competent authority to ensure that nothing goes wrong in the process of development of GMOs and their release into the environment. Now we go to the case-by-case principle in biosafety risk assessment consideration versus step-by-step. The underlying principle with GMOs, the approval of GMOs, is what is called case-by-case in their risk assessment, because no one GMO is the same as the other GMO. They all differ one from the other. Therefore, you must not apply the same risk assessment of one to the other. Case-by-case basis is an important element for biosafety risk assessment consideration, and the regulatory principle requires separate management considerations of each GMO application from the other GMO applications that are received by the competent authorities. The case-by-case is based upon the fact that each GMO event, including the genes that are inserted, for one of the GMOs, it could be the gene for herbicide tolerance. In the case of herbicide tolerance soybean, the other GMO could be to increase oil yield, or maybe heavy oil, maybe omega-3 fatty acids to increase it. The other GMOs could be to increase insect protection, like in the case of BT cotton, or BT maize, or BT cowpea, or even tera maize. Some could be for drought tolerance. So there are different traits that are being inserted, and this will determine the gene that is being inserted as well. It will also be selectable marker gene that is used, the promoter type, the product utility. Some could be for food, some GMOs could be for food, some could be for feed, and some of them could be for oil. It could also be the donor, that is the recipient organism that is receiving them. Where did you get this gene from? Did you get this gene from a microorganism? Did you get it from a plant? And all of those, are they available in the habitat that you want to introduce them to? All of those, they differ. The insulin gene was taken from a human pancreas and introduced into a microorganism. The vascular regenesis was taken from a microorganism and introduced into plants. So the source differ also. It could be transformation method. What method of transformation are you using? Are you using the agrobacterium tuberculosis as a method of transformation? That is the natural method. Or are you using something like the gene gun, or that is particle compartment? So all these methods are different. So, and therefore, it should require separate particular evaluation by authorities and the applicant as provided in the biosafety clearinghouse in order to ascertain the possible risks associated with the specific GMO under consideration. The case-by-case principle differs from the step-by-step principle. Please, can you go down? Can you go backward? Differs from the step-by-step. Go, keep going. Differs from the step-by-step. No, go backward. Go backward until the third slide. Yes. This is the step-by-step. From laboratory to greenhouse to confined field trial to food safety assessment and general release. This is different from the case-by-case principle. This is step-by-step in the development of the GMO. And each of those processes are being monitored and reviewed by the competent authority to ensure that nothing goes wrong. And if at any stage anything is found to go wrong, the whole process is reviewed or the experiment may be stopped by the FBA that is empowered by law to exercise a due diligence in the process. So FBA guarantees the safety of products that are being approved. Please, can you come down now? The applications of biotechnology are very diverse and and covers industry, health, environment, and agriculture. In our context here, our focus is on agriculture. And you have things like the benefits which have already been alluded to by previous speakers, like enhanced crop yield, and then the animal products, development of profit, insect pest protection, weed control, epilepsy tolerance, nutritional enhancement, which is otherwise referred to as biofortification, germplasm conservation, gene bank management, and then nutrient to water use efficiency, biofertilizers, and then value-added food products, value addition, etc. How are GMOs made? This is a simple illustration. Next slide, please. How are GMOs made? So with all the who and cry, this is a precise technology. A gene of interest is identified. That gene there with the red on it, as is identified, it is isolated and then introduced into an organism for which you want to improve. You see how it is introduced. It is identified, isolated, introduced into a promising line. So to have a genetically enhanced variety. So making a GMO transfers only the gene of interest and results in no undesirable transfer of undesirable genes, what we refer otherwise as gene linkage drag. And these are the two methods that are commonly used, either the agrobacterial transfer method or the particle boat method. There are other methods also. And like I said from the beginning of this presentation, that not all biotech requires creation of GMOs. Genetic engineering is used to solve intractable constraints. It is not just that scientists will wake up and they want to do genetic engineering for the fun of it. No. It is problems that have defied solution by conventional methods. That is where the genetic engineering is applied to solve those problems. Genetic engineering should be viewed as a form of gene transfer, which is an essential ingredient of crop improvement, especially applicable in difficult cases where such gene transfer is not naturally possible via conventional methods. The benefits of GMO, some of them have been highlighted. What you have on the left is BT cotton. That BT cotton confers protection against the cotton bollworm, Helicobacter pylori, which is a lepidopteran insect pest, which is one of the most serious insect pests of cotton. The one on the right is the tailor maize, which is drought-tolerant maize, and the insect-protected maize varieties, which is made available royalty-free to small-scale farmers. Next slide, please. This is BT cowpea. A lot has been said about it, so I don't need to talk about it also. This is the which is very, very important for the bioavailability of iron, zinc, protein, vitamin A, that's beta-carotene. And then it is important to combat hidden hunger that is associated with the micronutrient deficiency. And now this is a new development that has come up in the GM technology. It is a high lycopene-rich GM pig flesh. I wish to ask, how many of you have seen pineapple that the flesh is pink? Have you seen pineapple that the flesh is pink? Just look at that. The flesh is pink. No, pink flesh. Not orange flesh. Not golden. Pink. Pink flesh. It's not yet in Nigeria. It's a GM product. It is produced by the food giant called the Monte via a technology known as aerobic interference and grown in Costa Rica. I think it's also being sold in the US now. A colleague of mine told me he tested it recently and was so happy. It took them 60 years of research and development to develop this. Yet it is very, very good because lycopene is a very good antioxidant and it's also good for health. So all those people who have been crying foul to genetic engineering, which is part of the breeder's toolbox, people are looking for this pink-fleshed pineapple, which is also very, very expensive. Let me say just make some points on how this pineapple was created. The first presenter, Dr. Amin, when he presented the golden crop, he also talked about the isopregnant pathway for the creation of golden crops, like the beta-carotene crops. But within this same pathway too, there is metabolic engineering for high lycopene production. That gene that converts lycopene decyclase into beta-carotene by the enzyme lycopene decyclase is being muted, that is silenced by RNA interference. Because of the silencing of that gene, lycopene is not reconverted into beta-carotene, but it is caused to accumulate, thereby giving rise to high lycopene and then pink-fleshed pineapple. That is the technology behind this that has been done by biotechnology. There are several other biosynthetic pathways for the discovery and exploitation of highly beneficial plant genes, especially for enhanced nutritional quality and resilience. Some of them have Dr. Amin spoke about in the morning, especially for beta-carotene. So he said, do you know where biotech crops are grown? The first presenter also spoke about that, but I will just give you some of the references or highlight more on this. Please, the next slide. You can see North America, Canada, all of them, all the crops they have. Some of the points we hear sometimes is, okay, they are making GM crops and sending to other countries, but they are not growing. But they are growing GM crops also. And it's also in their food. Colombia, Chile, Argentina, Costa Rica, Mexico, Uruguay, Paraguay, Brazil. All of them grow. America, Canada, all of Portugal, Spain, in Europe, Spain, all of them they grow. And then in Asia, countries like China, Vietnam, Philippines, Indonesia, Pakistan, all of them, India, all of them grow. In Africa now, Nigeria, Ethiopia, and then South Africa, Malawi, and more recently Kenya, they are all growing their GM crops. Genome editing. This was the second speaker today presented on genome editing. So because of lack of time, I will not elaborate more on that. But this is a very precise and versatile revolutionary technology for genetic modification. And these are just about the people who discovered or who pioneered genome editing. But I want to emphasize the range of applications that have been developed with the genome editing in terms of medicine, drug case by case. If no foreign DNA is inserted, then it is not regulated as GMO, but it is treated like what? Like a conventionally bred material. That is what it is. Many countries have also used the same strategy in their GMOs followed. Now, what is One Health? The One Health concept approach is a holistic strategy that recognizes the interconnection between the health of humans, the health of animals, and the environment. As you said in that type of, next slide please. So you see the health of humans, because whatever affects animals, whatever affects the environment, invariably affects also humans. Diseases that can be transmitted between animals and humans and promoting overall well-being on a global scale. Due to the increase in world population, there is an increasing need to have more food and security and food safety, pest control, disease vector control, vaccines, and new therapies. What are the links between One Health and plant breeding and biotechnology? You need plant breeding through biotechnology. You need higher production. You need safer production. You need more adaptation to the environment and overall solving problems and making life better for mankind. So the one in the GMO development and then the challenges that are inherent in it is that one of the, I think it is this the youth representative, he was talking about the market, the farmer. It is the market that drives science and technological development. What the market needs, food, new vaccines, new drugs, and then there are also regulations. The warning is that the regulatory should accompany science. Science should form the basis of regulations and should not impair scientific development. Politics should not impair scientific development, but we should listen to science. Concluding remarks. Biosafety stewardship safeguards the health of the environment and ultimately humans. Biosafety regulations should accompany science and not create bottlenecks for progress in science and the advancement of human welfare. Where biosafety regulations are carefully applied, as in the establishing
Okay, let's move on.
Good morning. Are you going to share my slides or do I need to put them up?
I'm going to share the slide. Some moment, you have just some few moments. It takes some seconds to process. It's not the level of that.
Good afternoon, everybody. May I start?
Yes, please, Rashmi, you can go on.
Okay. Well, good afternoon, everyone, and thank you for inviting me to this workshop. I'm indeed honored. I wish it was in person, but it is what it is. So today I'm going to talk about biosafety and risk assessment procedures for food safety. Some of these points have already been covered, but what I would like the key messages to be is the comparison between non-GM and GM. Traditional plant breeding is considered to be safe. GMOs are safe. Traditional breeding is regulated, variety registration, etc. GMOs are regulated. They follow a scientific protocol in both cases. And the non-GM serves as a baseline for GM crop safety, which follows accepted international practices for food safety assessments. Differences serve as basis for further testing. So for those who may not be as familiar with the technology, what's the difference between traditional plant breeding and genetic modification? When you have traditional breeding, you have a variety that's a donor plant and a commercial variety. You breed together to get a new variety, which gives you multiple gene transfer, some that you actually wanted and others that you didn't. So there's an undesired gene, you'd have to continue to breed to get that out of there. Whereas with genetic modification, you have a desired gene insert and you can put it into a commercial variety using in vitro techniques. The only challenge or opportunity is that because the gene comes from potentially a different species, you have to go through a long process to prove that this is as safe as the conventional crop. So now just for, again, background purposes, what is biosafety? Biosafety, as per the WHO, is a strategic and integrated approach to analyzing and managing relevant risks to human health and plant life, and health and associated risks for the environment. It is based on the recognition of the critical linkages between sectors and potential for hazards to move within and between sectors with system wide consequences. And so there are actually 4 levels of biosafety risk, with level 1, which most labs operate under, a minor individual and community risk. Level 2, moderate individual risk. Level 3, high individual risk, but low community risk. But level 4, when you're doing something that's really complicated, is high individual and community risk. Now, another basic concept that I want to talk about a little bit is the difference between hazard and risk. You see an example here of the cat, which is going to get you as a hazard. And then there is the actual exposure by holding a cat. And then overall, there's a risk. It's hazard times exposure. So, with those things as background, let's look at how the food safety of GM crops is determined. When these safety procedures were going to be developed, lots of experts from all over the world gathered, and there was the issue that foods are complex mixtures which present unique challenges for evaluation of safety. At the time, we were used to standard toxicology studies used for new pesticides or new chemicals, and these are not appropriate because they're best suited to evaluate single chemicals. The various components of food provide nutrients which must be available in appropriate amounts. And any adjustments, either upward or downward, of single ingredients can produce physiological changes unrelated to the safety of the food being evaluated. Also, believe it or not, there are anti-nutrients in our food. A good example is potatoes. You can't eat raw potatoes because they have a toxic component. So we've learned how to use them safely. All international scientific experts and bodies consistently agree that what you have to do is show that foods derived from GM crops are as safe as foods obtained from conventional crops. So, how's this done? There's an integrated approach that has been developed by Codex and experts from all over the world. The key components of a safety assessment include a molecular characterization, a protein safety assessment, because you're going to be introducing a new protein, compositional assessment, which is to show that the modified plant is as compositionally similar, except for the new gene you put in there. There can be confirmatory animal feeding studies, but over the years, very few regulatory agencies require this. Agronomic and morphological evaluation is very important. That's the first starting point, because if a plant looks like, a GM plant looks like and behaves like a normal plant, except for the change you put in there, isn't the overall metabolism the same? And there might be additional studies on a case by case basis. But this multifaceted approach enhances ability to detect any unintended effects. The best part I like about it is over the years, I've worked closely with, I'm a toxicologist, but molecular biologists, protein biochemists, nutritionists, plant scientists, environmental scientists. So, next slide. The molecular characterization includes demonstrating the number of inserts. Always the preferred is single insert, single copy. The sequence of the entire insert, sequence junctions, so you can make sure that it is indeed what you wanted to put in there. The sequence junctions, these are important because to develop specific detection methods, you need to know that sequence. The next part is any presence of backbone or other small inserts in the plant. So the molecular characterization is perhaps the most complicated part of this. The next step is the protein safety assessment. And there are 3 different components of it because you're putting in a new protein in there. First of all, you want to know if the protein you're introducing in there has a history of safe use. For example, Bt proteins, which are put in there for insect protection, Bt sprays have been used for years, so we know they're safe. The question is the Bt gene that you put in there, is it safe? So with that, you know the familiarity, you want to understand what is the exposure. The next question is, since allergenicity, because we know that all allergens are either proteins or react with the protein to become an allergen. So first thing you want to make sure is the source of the organism. Does the gene that you're trying to put in come from an allergenic source? That's a no-no. And the next step is bioinformatics. These techniques have been developed by comparing the protein you're going to introduce with known allergens. You can find out if there are matches, and that's what bioinformatics does for you. The digestive fate is important because proteins that are allergenic generally tend to be stable proteins. So you want the new protein that you're introducing is not a stable protein. And then there may be some specific IgE binding if the similarity to a known allergen. The other part is the toxicity of the protein. Very few proteins are toxic, but you can, again, run bioinformatics to see if this has any relationship or similarities to known toxic proteins. One common study that is done in all is the acute mouse gavage study for the protein in question to show that it's not toxic. I should point out that most proteins that are toxic are acutely toxic. So this is a very important information gathering. And then anything else based on the information that you have on that particular protein. And I think that since the entire safety system is based on how much have you changed the composition of the product, the question becomes, what do you analyze for the for the crop? And OECD has actually put together a list of crop-specific toxins, secondary metabolites, and or nutrients. And these are things, the composition analysis, you have approximately 50 analytes for soybean, and 70 for corn. So the question becomes how much systemic differences in components should be linked and assessed against natural variation. And this is where the OECD has put consensus documents, which gives you the variability of the proteins, etc. There's also a LC database which has the crop composition. The question then becomes, if there is a compositional difference, the statistical significance is there, but is there a biological significance? It's important because from a statistics point, at a probability of 0.05, a chance results one significant difference for every 20 comparisons. And there are, hundreds of comparisons that we do. So the question then becomes, which statistical change is really biologically significant? So that composition studies are relatively complex, but easy to do. Anybody can do them if you have this background knowledge. Then comes the question, do we need animal feeding studies? And this is a tough question because the animal feeding studies are most useful when you have a testable hypothesis. For example, the composition of the GM plant is moderately or modified substantially. Most cases, that's not the case. Indications of possible unintended effects based on what you've seen in the molecular, compositional, and agronomical analysis. Very seldom does that happen. So the difficulty is that animal feeding studies are kind of hard to do with foods and feed because what you're putting in there is a new protein at a very, very low level. And you can never get enough of the feed by just increasing the content of that protein. You have to lower other aspects of that. There's a limit on how much you can change it and maintain a nutritionally balanced diet. So very few regulatory agencies actually require animal feeding study in a new GM crop. The one example is the European Union. But if it's required to be submitted, then other countries would like to have the data also. So having developed all the data for the safety of a new GM crop, now comes the important question. Have you identified a hazard? And is there exposure to this hazard, which is your risk assessment? So what is risk? Risk is the possibility to suffer harm. And risk is equal to hazard times exposure. For there to be risk, both of the following must be true. There must be a hazard that can result in harm, and there must be sufficient exposure to that hazard to actually cause harm. As I said, these proteins that are introduced into the GM crops are at the parts per million level. So they're very, very low. And so there is very low potential for sufficient exposure. And the hazard, most proteins are safe. So overall, the risk is low. So thus, in summary, the process for safety assessment of ag biotech crops involves a broad integrated, comprehensive, science-based approach developed by global technical organizations. It actually started with meetings in the OECD and the FAO, WHO, and Codex then developed the Codex standards. And it usually is comparison of the transformed plant with a conventional plant to show substantial equivalence and safety of the newly inserted protein. So, detection of potential risks to human, animal, and environmental health. You look at all three of those, not just food safety. Assessment for potential harmful unintended effects. And a case by case approach that can be used for agronomic and improved nutrition traits. And that's all I have to say. I thank you for your attention. Be happy to answer any questions that you may have.
Our last speaker, Mrs. Mukwilona, are you ready?
I am trying.
Are you with us?
There we go.
There we go. Okay, go ahead.
Hello?
Okay. Hello? Okay. Okay, Rashmi, I don't think there is any question for you. At the moment, yeah. And if there is, Matudo is there.
Would you want to share Yeah, do you want me to share from here or?
Okay, you can share from there if you can. No, this is not true. This is true. It's another platform. Which one? Which one? On the street. Oh, it's over there.
Hello, can you hear me? Can you see my screen, please?
Yes, I can see your screen.
Okay then. Thank you. Good afternoon, everyone. Please permit me to stand on the existing protocol. We've heard quite a lot since morning today on the pros and cons of GM food. But my presentation is to build our confidence as consumers on the safety of genetically modified food, feeds, and compliance with international protocols. As outlined my discussion topics, and by introduction, we know we are consumers, we are all consumers, and the consumers are one of the core stakeholders on GM food because they are the end users. By the United Nations guidelines of 1955, consumers have some rights. Right to satisfaction of basic needs, right to information. I heard some people asking, why is it that we are not labeling GMO earlier today? Right to choice, right to representation at fora, different fora, they should be able to talk on their behalf to ensure their safety and all that are protected. Also, right to safety, which is the topic of my discussion, right to healthy environment so that the future generation is preserved for now and for future. They have rights, one of which is the right to safety, that the goods and or services they consume and their production processes are of good quality and are safe. So you can see that it is the right of the consumers to be concerned about the safety of new products about to enter the market. And I know we all know that GM products, goods, food, they are no longer new. They are no longer new on a more serious note. So my presentation is to let us know that there's nothing to fear in spite of all what we've heard here today. There's nothing to fear, and I want to explain to you what I've seen, I've known, and the fact behind this conclusion. And we have some terms about safety, the agency, commercial release, modern biotechnology. Consumers, people, you and I are consumers. We purchase goods and services. The Federal Competition and Consumer Protection Commission has its own definition of consumer as well. And consumer behavior has to do with how consumers make decisions about what to buy, when to buy it, and how to do so. It refers to the actions of the consumers in the marketplace and the underlying motives for those actions. Consumption pattern, what are the various factors that affect how consumers make purchases in the market? That it could be psychological, inward drive to get what they want, self-interest, everyone wants to know what is in it for them, difficulties or barriers of getting access to those products. When it was mentioned earlier that the farmers, they already been bought in, that they should consume, they should plant GM food now. But they said they couldn't get the seeds. So that could be a difficulty, it could be a barrier, a factor that influence what they plant or what they don't plant. Perception, they want to know, is the product safe? Those are the things that consumer will consider before they make purchases or they eat anything. Culture also has influence in putting pork gene into some product. Some religion will not permit that. It could also have to do with their attitude, trends, personality, and experience. Another factor is the fear of the unknown. Hence, this workshop we are having today to encourage consumer advocacy, awareness, sensitization, in order to, from correct sources, to allay their fear, but there's nothing to worry about. Genetically modified organism, we have got a lot of definitions here today. I will not go much about that. I will not talk about that. Nowadays GM crops are incredibly common all over the world. In South Africa, not only in US, many people are already growing. The figure is increasing for other countries around the world. We've heard a lot about the advantages of GM crops today, improved yield, nutritional content, and so on and so forth. And then potential safety concerns. A lot have been said here today as well. This could be due to the introduced foreign protein. Allergic reaction may occur because of that. But I can tell you, even food crops or food items from the wild, some people are allergic to them. I know some people that are allergic to fresh seafood. Some are allergic to nuts, and they are from the wild. They are not GM. So it's not really limited. Allergenicity is not limited to only GM food. Also, it's a common concern that GM food may lead to progression of cancer. Since cancer is caused by DNA mutation, they said this one is also unbased, it's an unbased fear. There currently no human research ties GM intake to cancers. The American Cancer Society and other medical associations have confirmed there is no evidence that link GM food intake to an increase or decreased risk of however, of cancer. However, further long-term human studies are actually recommended. Effect on the environment. Effect on the environment, the use of a Roundup, a brand of pesticide that contain glyphosate when planting GM crop, and that this may have negative impact on the environment. The fact is that most farmers, including those planting conventional crops, use Roundup to control pests. Even the advantage with GM crop is that there is need for only fewer applications. This is positive for the environment and a plus for the GM crops. Toxicity, a lot have been said here today. Risk assessment is usually carried out to make sure that no way with this product, once it is properly approved and released, there's no way it can have any effect, negative effect on the consumers. And the current research findings have proved that GM fruits are no more harmful than conventional, or toxic. They are no more toxic than conventional foods. And the measures have been put in place. A lot have been said by the representative of the DG of National Biosafety Agency, Mrs. Bello was there. I could see her earlier today in that program. And they have a lot of activities. We can refer to the biosafety bill. You can Google it. There are some publications. We can read further on this. A lot of functions of these agencies to ensure that the GM food are safe, and they also ensure compliance with international protocols, implementation of the provisions of the International Convention of Biological Diversity, and the Cartagena Protocol on Biosafety and Kuala Lumpur Protocol on Liability and Redress, or matters related to they ensure compliance. The setting up of some monitoring committees, institutional committees, establishment of a lot of committees to ensure that these products properly they are properly assessed before they are approved for release to the market. They carry out confined freeze trial, they do risk assessment and so on and so forth. And for consumer safety and protection for the environment in case of accidental or unintended release, remediation measures will be undertaken. And these measures, I'm talking of the confined freeze trial, risk assessment, proper regulation were strictly applied before the releases and commercialization of the already released BT cotton, BT cowpea, and most recently the teller maize, the water efficient maize in Nigeria. BT cotton, a lot have been said here today too. Nigeria approved the release of this. It is pest resistant and yield improves. Farmers are benefiting financially from this. And the cowpea, the first genetically modified food crop in Nigeria, it has been genetically modified to resist the destructive pod borer, insect pest, Maruca bitrata. This new variety of a cowpea carries a gene of from Bacillus thuringiensis, a sub-bacterium that's naturally occurring, so it has no fear of toxicity to humans. You know, the world's first GM cowpea variety developed by Nigerian scientists. Risk assessment has shown it is safe for human and animal consumption with some other added advantages. They say it's easier to, it's cooked faster, it's very robust, it's tasty, and all that. The crop is expected to support the nation's economic development and food security while improving the farmer's income. Most recently, we have the teller maize, which is insect resistant and drought tolerant, was approved for release and commercialization. It's the second food crop after the BT cowpea to be released. They said it gives higher yield of 10 tons per acre compared to the regular one, which is about 6 tons per acre. So that's a lot of improvement. Also for future releases, which are usually on case-by-case basis. These measures that National Biosafety Agency has put in place and other support organizations, they are to ensure that those products are safe. They are safe before they apply, before they are approved and released. There are pronouncements to support the claim that GM crops and food they are safe for consumption. There are pronouncements by notable international organizations on safety of GM food, and notable and reputable organizations such as the World Health Organization, Food and Agricultural Organization, and may pronounce safety of GM food. The FAO says different GM organisms include different genes started in different ways. This means that individual GM food and their safety should be assessed on a case by case. I've said that earlier, on case by case basis. And it's not possible to make general statement on the safety. Yeah, that's why when the government releases any, they don't lump sum them. They take them one by one, do thorough investigation before it is released. GM foods currently available on the international market have pass safety assessment, and they are not likely to present risk for human health. That's a pronouncement by the International Organization. In addition, no effect on human health have been shown as a result of consumption of such food by the general population in the countries where they have been approved. However, continuous application of safety assessment based on the Codex Alimentarius principle. You know, the Codex Alimentarius Commission is the world body responsible for the quality, safety, consumer safety, and the trade in food. Their principle, and where appropriate, adequate post-market monitoring should form the basis for ensuring the safety of GM foods. The American Food and Drug Administration and Environmental Protection Agency, US Department of Agri can all maintain that GM food are safe for human and animal consumption as well. And just about any major medical association in the world over agree that approved GM foods are safe. The next one I want to talk about, let me go back a bit. So from all indication, we can see that we are all in this together. We are all in this together. The just a minute, please. Researchers and the promoters of GM food, they are all consumers too. They are all consumers. They will buy from the same market. They do not want to suffer any ill health, or die young, or cause any harm to anybody. So in conclusion, we can conveniently say that GM food and feeds are not less safe than conventional food. The products of biotechnology have been consumed for a while now in other parts of the world. And in Nigeria, you know, Nigeria too, nobody's using us as guinea pig. Even the farmers said they want the seed to plant because they've been eating and nothing is wrong. Most of the people in the hall there, they have eaten GM food before, and nothing, have eaten before, and then we are all good to go. So with all this measure put in place, we are good to go and consume GM food. However, there is always room for improvement through research and development. Those are the references for this presentation, and thank you all for listening. In case there's any comment or questions, let me know. Thank you.
Thank you so much for that brilliant presentation, Mrs. Akeju. Any comments, observation? Okay. Please make it brief. I'll make it brief. Thank you.
I have to share one concern. I don't know whether it's still retreated. Mention of time. How do we assess these seeds? We need it. That is one of the key things. Is it accessible? How? How will it get to farmers? Will you use what framework or another platform other than AFAN? Let us know. Or government platform. Let us know before we do. Thank you.
Okay, thank you. To address your
Can you hear the comment, please?
Okay, no, that's not for you. The farmers are asking if they get the seeds. And which has been the case for so many farmers. From our farmers' engagement last week in Abuja, an assurance was given to all farmers that be rest assured, if we're not able to meet up with this farming season, next farming season, adequate seed will be made available to all farmers. Through the All Farmers Association. Yeah, definitely. Because the Minister of Agri was in that program, Minister of Environment, Minister of Health, all of them, and Minister of Science and Tech were all in the room when that assurance was made. And they stressed the need for the seeds to be readily available because all of the farmers are clamoring, where are the seeds? Some have actually gotten. I was there, and I could testify to that. But it was not enough because you know the numbers of farmers we have in this country. Will it be free that? That I can't give you tentatively for now. But be rest assured, the Ministry of Agri is involved in this, and the President of All Farmers Association was with us and he has always been with us. Thank you very much. So at this junction, I will want to call on the Deputy Vice Chancellor, Professor Aguze, for a wrap-up. Thank you very much.
everybody. Are we still awake?
Yes, sir.
Good afternoon, good afternoon, good afternoon. We have come to the end of this very informative and enriching workshop. For those of us who have been here from the beginning to the end, you will agree with me that it has been a very, very enriching workshop. Enriching in the sense that there has been so much information shared from different resource persons within Nigeria, outside Nigeria, and from different perspectives. Let me, on behalf of the Vice Chancellor of our university, Reverend Father Professor Christian Anyeke, thank you all again for choosing our university to host this workshop for the southeast part of the country. It is indeed a great privilege, and we are very, very appreciative of this honor. We thank everybody who has traveled from different parts of the country to be here. We wish you safe journey as you return to your various destinations. We also hope that this workshop will continue to help us in our various sectors, various institutions, and various endeavors in life to continue to think of the alternative ways which GMOs provide for us in combating the threats of food insecurity in Nigeria. It is becoming harder, tougher, more challenging for the average Nigerian to afford basic food. This morning, the news has been trending that a cup of garlic is now 300 naira from 100 naira. And the bag of garlic is now 72,000 naira. Garlic. And the same thing applies to all kinds of food in the country. Therefore, there is urgent need